Uh, Good morning. Good morning, everyone. Good morning. Good morning. Today, optical instruments theory sections we are starting. Okay. So most probably, good morning, everyone. Most probably, you will get the tutes by next week for sure. You will get them by next week for sure, right? So today we have to start optical instrument section, but I know that since you haven't received the tutes yet, it's a small problem, but today manage it. Today manage it. I have shared the PDF of that optical instruments in the group. I shared the PDF of the optical instruments and IDFIT tute in the group. I shared. Okay. I shared that. Right. Okay. Today manage it. Today refer that PDF and manage it. Okay. Refer that PDF and manage it today. We'll start the story. And okay. Right. Mm, okay. Give me one more minute. Now in that PDF, first section is IDFX section, but first we are covering optical instruments and then only we are coming to IDFX section. Okay. So therefore we are starting page number 19. Optical instruments, page number 19. Visual angle is our main story. Visual angle is our main story. Okay. Okay. Right. Okay. Right. Mm, okay. mm, Give me 1 minute. Okay. Okay. Optical instruments, next section. Right. Optical instruments. Optical instruments. That means microscopes and telescopes. Mainly we discuss under this section. Optical instruments. Okay. Right. Then, under this section, first point is you want to understand what is visual angle. If not, we can call it as angle of vision. If not visual angle, what does it mean? Visual angle, right? Visual angle. The symbol for the visual angle is normally we can mark alpha. For the visual angle, we can mark alpha normally. We can mark alpha, but right? Visual angle is alpha. 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 Today, now take your notebook and just manage writing the things and all. Once you get the tute, write them in the tute, okay? Visual angle is alpha. Right. What do we mean by visual angle? Now, let's see that now we are observing an object. Now, there is an object. You can consider a pencil in front of you. Now, you are looking at the pencil, right? You are observing the pencil. Okay, right. First thing is, I will tell you now. Uh, we are discussing ID fix section bit later. First thing I will tell you that now, if you can see an object clearly, for an example, in front of you there is an object. Just take it as a pencil. Now you are able to see that object very clearly, right? So, if I try to explain that scenario, you are observing the pencil. Pencil is the object. Your eye. Your eye is behaving kind of a lens. That is a convex lens. Okay. Generally, remember, our eye behaves as a kind of convex lens. Okay. Right. So this is how normally we represent the eye. Then this part is the convex lens. It's a convex lens. Just think this horizontal line as the principal axis of this convex lens, if not eye lens. Okay, right. Now what happens now? What happens? Eye lens, that is a convex lens. It's a kind of convex lens. When we keep an object in front of the eye, if you keep an object in front of the eye, let's say now my object is capital O is the object. Object is capital O is the object. Okay, right. So if you can see this object very clearly, the meaning is, remember, the image of this object is formed exactly at the retina of the eye. So we will talk about retina and that story a bit later. But remember, if an object, if you are able to see an object very clearly, means the meaning is image of that object has formed exactly at the retina of the eye. How many of you heard about retina hands? How many of you heard about retina hands of retina? Raise your hands. How many of you learned about retina, heard about retina hands? We all know what's retina, but when I do eye defect section, I will explain the parts of the eye and I will explain the idea. But roughly remember, retina means this region. Roughly think, I think most of you doing bio, therefore you all know better than me. Retina means this region belongs to retina, right? Very clear. Eye lens is a convex lens. When an object is clearly visible, then this is the object. The image of this object must be formed exactly at the retina. Image of this object must be formed exactly at the retina. Right. If I draw the image of that object formed at the retina, this is the image of this object, right? This is the image of the object formed at the retina. Okay. Normally remember, for a convex lens, right? Your eye lens is a convex lens. Therefore, the image formed at the retina is always inverted image. That's what to keep in your mind, right? Normally, if you see an object, if you are see a pencil, right? If you're looking at a person, right? The image of that person formed at the retina is always inverted. But why we are able to see the person same as up and down normally, right? That's a person, actually person. We can see on top his head is on top and his leg is at the bottom, right? Right. But when you look at the person from your eye, the image of that person, the form of the retina is inverted image. It's an inverted image. Even though it's an inverted image, how you are able to see the person exactly his head is on top and his leg is at the bottom? Because our brain identifies that. Our brain identifies that even though image formed on the retina is inverted image, actually object is upright. Therefore, our brain is modifying that data. Therefore, we are able to see the object upright. That is the idea. Okay, simple. That's really simple. Okay. Then idea clear? Then object is here. Then this is the image. Summary, what you want to understand is summary. I want to explain what is visual angle. Visual angle means when you keep an object in front of the eye. Eye lens behaves as the convex lens. Generally, if you can see an object very clearly, the meaning is image of that object must have formed exactly at the retina of the eye. Then only we can see an object clearly. In case if you are not able to see an object clearly, that means if you notice the object is a kind of blurred thing, then remember image does not form at the retina. That's why if the image does not form at the retina only, you see that image blur, you see that object blurred, right? Not clear. Okay. Then okay. Right. Image is capital I. Remember, angle of vision means angle subtended by the object at the eye lens. Angle of vision, visual angle means angle subtended by the object at the eye lens. Angle subtended by the object at the eye lens. That is what we call as angle of vision. right? Angle of vision. That means if I draw a light ray emitting from topmost point of the object, right? Okay, right. This is a light ray. Okay, light ray. This is the image. Capital I. Angle of vision means angle subtended by the object at the eye lens. That means this angle is alpha. This is what we call as angle of vision, if not visual angle. So first what you do that in the tube there's a space, right? In the tube there's a space, right? Visual angle, angle of vision, right? Suppose an object is placed in front of the eye. Let's capital I be the image formed on the retina. Capital I be the image formed on the retina. Okay. I have given a space. In that space, write down. In that space, write down. In that space, write down. Visual angle is the angle subtended by the object. Visual angle is the angle subtended by the object. Visual angle is the angle subtended by the object at the eye. At the eye. At the eye. Visual angle is the angle subtended by the object at the eye. Right? Then very clear. Here is our object. Here is the eye lens, the angle subtended by the object at the eye lens. That is the visual angle alpha. So from the vertical opposite angles, you want to understand this angle also alpha. From the vertical opposite angles, you want to understand this angle also alpha. This angle also alpha. Right? Quickly draw this diagram. Object is a straight vertical line, but when you are drawing the image at the retina, just draw a kind of curvy image. When you're drawing the image at the retina, just draw a kind of curvy image. Okay? Finish drawing, raise your hands. Finish drawing, raise your hands. Visual angle. Visual angle. Visual angle. Quickly draw it. Once you finish drawing, raise your hands. Once you finish drawing, raise your hands. Visual angle. Mark this alpha as visual angle. Visual angle. Right, me? Now, why this visual angle is very important? The reason is because we see the magnification. We see the magnification based on the visual angle. That means we identify that, for an example, one object is larger, right? Another object is smaller. That magnification we identify because of the visual angle, right? So we know that we'll explain this idea. Visual angle, so I will explain, right? Just consider there are two objects having different heights, different sizes, right? There are two objects kept in front of the eye lens. Those two objects have different heights. Okay. For now, example, object 1. I mark in red color. Object 1. Okay. I mark object 1 in blue color. First, object 1. Object 1 is kept in front of the eye lens. Object 1. Okay. Object 1. O1. Then shall we find the angle subtended by this object 1 at the eye? If not visual angle of object 1, the visual angle of object 1 going to be, if I draw a light ray emitting from topmost point of the object 1, the visual angle of the object 1 going to be like this. Okay. Right. Alpha 1. The image of this object 1 formed exactly at the retina. If I draw the image of object 1, it's going to be like this. Image of object 1 is I1. I1. Angle of vision, that is going to be alpha 1. That is going to be alpha 1. This angle is alpha 1. Alpha 1. From the vertical opposite angles, we can consider this angle is also alpha 1. This angle also alpha 1. That's what to keep in your mind. Now what I'm doing that, I'm not changing the location of the object 2. Object 1 and another object 2 both are kept at the same location in front of the eye. But size of the objects are different. Object 1 is smaller in size. Object 2 is larger in the size. If I draw the object 2, right? Red color one is going to be the object 2. Red color one is going to be the object 2. Okay? Object 2. That is, I mark it as O2. O2. Object 1 and object 2 both are at the same point, same position. If you draw the, if you find the angle of vision, visual angle for object 2, if I draw a light ray emitting from topmost point of the object 2, the visual angle of object 2, right? The visual angle of object 2. Oh God. It's okay. The visual angle of object 2, somewhere here. Then if I draw the image, right, the visual angle going to be, this is the angle, visual angle for object 2. This visual angle going to be alpha 2, right? If I draw the image formed at the retina of the object 2, that is going to be like this. I draw like in here, if I draw somewhere here, but, right? You can't see any. You can't see the idea. Okay. The image formed at the retina, that is capital I2. Capital I2. So one point is very clear. When there are two objects having different sizes at the same location, the visual angle formed by those objects at the eye are different, right? Different sizes at the same location. Different sizes at the same location, the visual angles formed by them at the eye is different. Very clear that in this scenario, object 2 creates a larger visual angle, object 1 creates a smaller visual angle. No doubt, that's totally clear. So we can tell that alpha 2 is larger than alpha 1. Right, me? Okay. Now what if, do you think, ratio and someone if we say that? Just consider the same object. That means object 1 only. Now we know when different objects having different sizes, yeah, obviously they create different visual angles at the eye. No doubt, me. Based on the size and location. Based on the size and location of the objects, yeah, they create different visual angles. Just consider same object in same size, same object. So what you are doing that you are moving the object different positions in front of the eye. If you are moving the object at different positions in the eye, in front of the eye, ratio and homography say that will visual angle change and Even though same object, when we move the object at different locations in front of the eye, even though it's the same object, same size, definitely visual angle will change answer, right? Visual angle varies. That story also I will explain. That story also I will explain. The next story, next story, the next story, the next idea, next idea. This section is a really nice section. Normally, normally they ask in the optics, if they ask essay question, most of the essay questions they are asking from optical instruments, mostly, right? Not true, not, I think essay question from Prism, I think very rarely they are asking. Essay questions from refraction of light through plane surfaces, they are asking, but most of the essay questions, when you check them, all the essay questions almost they are coming from optical instruments and IDFX. They combine together. Optical instrument section and IDFX section together, and only they are asking essay question. Therefore, this section is very important. Very important. Okay. If I draw the principal axis of this eye lens, this convex lens, okay, right. So now what I'm doing actually, right? Same object, but at two different locations. Same object, but at two different locations. Okay. Uh, Object is, let's say, O1. Object is O1. Then, object is somewhere here. Object is somewhere here. Then it is O2. I move this object from this point to somewhere here. Then object is the same object only, but I name it as O2. Same object, I name it as O2. Right, O2. Shall we find the visual angle produced by object 1 at the eye? Visual angle produced by object 1 at the eye. If I draw the image, if I draw the image formed by the object at the retina of the eye, this is the image formed by the object 1 at the retina of the eye. You can't see this red color mark, right? But understand, there is the image. Okay, that's the image. You can't see it clearly, but understand that's an image, okay? Right? Capital I1. Capital I1. Okay? Right. Then the visual angle of object 1 at the eye is alpha 1. This angle, this angle going to be what? This angle going to be alpha 1. This angle alpha 1. Right? Now, when the object is placed at a point far from the eye lens, compared to the previous location of the object. When the object is placed far from the eye, compared to the previous location of the object. Now, object distance is larger. Okay? If you draw the light ray emitting from the topmost point of the object, if you draw the light ray emitting from the topmost point of the object, passing through the optical center of eye lens, passing through the optical center of eye lens, in that case, so you have rulers, right? When you are doing the diagram, use rulers and nicely do the idea. Okay, now just because you have to write down the stories in the tute, don't just roughly write down everything, write neatly. Later on, just take some time and convert it into tute. Okay, right. This story. Okay, right. Then the image of object 2 formed at the retina, that is I2. That is I2. This image is I2. Capital I2. If I mark the visual angle produced by object 2 at the eye, that is alpha 2. is the visual angle, right? That is alpha 2. So very clear that when the same object is closer to the eye, visual angle is larger. Same object is far from the eye, visual angle is smaller, right? The best example is now if you look at the moon, but obviously we know that moon is almost same size as the entire earth, right? If you consider this object as the moon, consider object as the sun, right? Sun is very huge than the earth also, right? If you consider your size and earth size, you are negligible, right? When you consider earth size and sun size, sun is very huge. But even though sun is very huge, we see the sun. When we look at the sun, we see the sun very small object. Why? What is the reason? Now you should be able to explain why, even though we know practically we know that sun is a really huge object, no doubtly. Sun is very huge. But when we look at the sun, we see sun as the very small object. What is the reason? If not, the next example is now let's say now there's a ship. When the ship is very far in that sea, now you are in that seashore, what we call, you are in that seashore or whatever, right? That ship is very far from you. Then you see like the ship. Ship is the object. We know ship is very huge object than you. When the ship is at very far distance, we see like ship is like a small point object. But when the ship comes closer, you see like it's a very huge, very massive object. What is the idea? The reason is what? Because very simple, even though objects are very huge, when they are very far from the eye, the visual angle produced by that object is very small. That's why we see those huge objects as very small objects. Do you understand? But even though, remember, deciding factor is not the size of the object. You are seeing object in large or in small, not because of the size of the object. Now, one can't tell that now since ship is very huge, since sun is very huge, visual angle should be very huge. No, you can't tell that. Even though doesn't matter, object size is very huge, doesn't matter. Based on the location of the object, visual angle varies, right? Then we can get an idea. Conclusion is very simple. That means you are coming to tell that our eye determines the size of the object. Our eye determines the size of the object or image based on the visual angle, right? The deciding factor of an object size is visual angle, right? Even though doesn't matter what is the size of the object, even the small, just a small needle, it's a very small needle, right? When you keep this needle nearby your eye, it creates a very huge visual angle. Therefore, you feel like needle is very large. Even the very huge sun is very far from you, very far from the eye, it creates a very small visual angle. Therefore, you see the sun as a small object. Even though needle, if you just take the ant, a small ant, even though ant is very small animal, very small animal, when you keep the ant nearby your eye, it creates a very large visual angle. Therefore, you see like ant is very huge. Summary simple. Summary simple. Size of the object. Size of the object that eye determines based on the visual angle. Large the visual angle, eye determines object as large. Small the visual angle, eye determines object as small. That is the idea. Right? That story crystal clear and sound. That story crystal clear and sound. That story crystal clear and sound. Now I can explain this idea. See this idea, same story only. I will explain in terms of image sizes. I told you based on the visual angle, I determines objects as large or small. Right? Now why? Because based on the visual angle, what's happening here? Sir, large the visual angle. Let's see this story. Alpha 2, red color visual angle is larger than alpha 1. Remember, larger the visual angle, larger the image formed at the retina. Larger the visual angle, larger the image formed at the retina. Smaller the visual angle, smaller the image formed at the retina. Right? Remember, based on the visual angle, size of the image formed at the retina are different. Right? If the image formed at the retina are different based on the visual angle, eye identifies different and is small or large, right? Even the same object, based on the location, visual angle changes. When the visual angle changes, image formed at the retina changes, right? Even the same object, when you place at different locations, the visual angle produced by them and the eyes are different. When the visual angle is different, image formed at the retina, size of the image formed at the retina are different. Since this object 1 creates a larger image at the retina because of that large visual angle. Since object 1 creates a larger image at the retina because of the larger visual angle, I determines object 1 as large object. Even the same object, since it is very far, the image formed at the retina is very smaller because of the smaller visual angle. Right? Therefore, I determines this object as a smaller object. Right? That story, that is the overall idea. I think that story is clear. That story is clear. What you want to do is in the tute, that idea done. Visual angle story idea clear. Visual angle story idea clear. Now write okay. Okay. Right in the tute, what you want to do is in that given space, I asked you to draw this diagram, this story done. Then important, the magnification. Now see, read that. The magnification of the image is determined by the size of the image formed at the retina. Clearly, the magnification of the image is determined by the size of the image formed at the retina, which depends on the visual angles obtained by the object at the eye. Right? Right? Which in turn depends on it. Correct that. Which in turn depends on the visual angle subtended by the object at the eye. Right? In that given space, you want to draw this diagram and this diagram. Draw those two diagrams. Right? And highlight that important point entirely. The magnification of the image is determined by the size of the image formed at the retina, which in turn depends on the visual angle subtended by the object at the eye. Right? Now, summary is very simple. Now, mark here. Here, mark this diagram. This diagram, write down different objects in different sizes at same location. Right? So, when you are drawing this diagram, write down objects objects with different sizes at same location. Objects at different sizes at same location. This scenario. Same object at different locations. This scenario. Same object at different locations. This scenario. So we understand that when the object is very far from the eye, visual angle is smaller one. So therefore we know that alpha 1 is larger visual angle when the object is very closer to the eye. When the object is very far from the eye, visual angle alpha 2 is smaller. This story. From this entire discussion, what you want to understand is summary. Magnification of the image. Right? Magnification of the image, that depends on what? That depends on the size of the image, because same object, magnification of the image depends on the size of the image. Size of the image depends on the visual angle. Right? Magnification of the image, capital lim, depends on what? Depends on the size of the image. Size of the image means you can tell HI or whatever. Size of the image. Size of the image depends on the visual angle. Visual angle, right? Even the same object, right? Even the same object, based on the visual angle it creates, size of the image becomes different. Since the size of the image is different, magnification of that image is going to be different. Okay. Larger visual angle. If an object produces larger visual angle, larger image size, therefore larger magnification of the image. That is the idea. The story is right down there. Nice story. Now I have a good understanding. Genuinely hands up visual angle idea, the story. What is visual angle? Right, even the same object, when the visual angle changes, what will happen to the image of the retina, image sizes, then magnification. That idea crystal clear answer. Once again. Once again, that idea crystal clear answer. That idea is very clear answer. That idea is very clear answer. It's very clear. It's very clearly. It's very clear. It's very clear. Finished writing answer. Once you finish writing, raise your hands. Okay, right. Once you finish writing, raise your hands. Once you finish writing, raise your hands. Okay. So then go to the tutor and read that. Even if the object remains the same, even if the object remains the same, when it moves farther from the eye, the visual angle decreases. As a result, the object appears smaller. Hence, it is clear that the first point write down. Hence, it is clear that first point write down. A larger visual angle produces. A larger visual angle produces. A larger visual angle produces, comma, a larger image on the retina. A larger image on the retina. A larger image on the retina. That blank, next point write down. Next point write down. A smaller visual angle produces. A smaller visual angle produces. A smaller visual angle produces, comma, a smaller image on the retina. A smaller image on the retina. A smaller image on the retina. Retina, please name the retina, okay? This region is retina. Retina. Nice story done. And now only we will go to the optical instruments. Optical instruments, mainly we talk about microscopes and telescopes. Now, before going in deep about microscopes and telescopes, just think, why are we using microscopes and telescopes? Reply, everyone. Reply. I need some replies from all of you. Right? I'm expecting replies from all of you. Why do we need, why are we using microscopes and telescopes? Why are we using? Reply. Everyone reply. Right? Everyone should reply. Why are we using microscopes and telescopes? Reply, everyone. Reply, everyone. Reply, everyone, quickly. I'm expecting responses from everyone. Everyone. Amina, Shikma, Senistika. Then who else? Amaya. Hi, Amaya. Fasrina, Kanishka, Noha, Rifana, Shane, Sharaf, Tulasika, Zikra. Why are we using microscopes and telescopes? I'm expecting responses from everyone. Why are we using? Why are we using microscopes and telescopes? To see the enlarged view of an object. To observe a magnified image. To observe a magnified image. Magnifying small object. Then observe magnified images or small objects. To see the object that are far away from us, that object that are too small. To see things we can't see from our naked eye. To enlarge the view of an object. Okay, right, me. Nice story, nice. Okay. So what we understood from this idea is, even though there is a very huge object, if it is very far from the eye, even though there is a very huge object, it's a really massive object like a sun, which is very far from the eye, very huge object, but it is very far from the eye, right? Then you see, you are not able to see this object clearly, right? Even though it's a massive object, if it is very far from the eye, you are not able to see this object clearly. The reason is what? Why you are not able to see this object clearly? It's a very huge object, right? But because it's really far from the eye, the visual angle, right? The visual angle produced by this massive object at the eye is very small. Visual angle is very small visual angle. Since the visual angle formed at the eye is very small, the image formed at the retina is very small image. Because the image formed at the retina is very small, eye is not able to see this object very clearly. Right? The problem is what? The problem is why, even though it's a massive object, why we are not able to see the object clearly? Because of its far location, visual angle it created on the eye is very small. As a result, the image formed the retina is very small. Right? Okay. The next story is there is an object that is very small, a bacteria. That's an object. There is an object that is very small object. Take a bacteria something. Take a bacteria something. Take a small bacteria, a small dust particle. Actually, that dust particle is really close to your eye only. The dust particle is really close to your eye only. But why still? Why that? Why still that bacteria is very close to your eye only? But why still you are not able to see the dust particle clearly? Even though that dust particle, that object is very closer to the eye, since it's really small in size, the visual angle created by the dust particle, that bacteria on the eye is very small, very small. Therefore, the image formed by the dust particle, that bacteria at the eye is very small, very small image height, very small image. That's why we are not able to see that dust particle, that bacteria very clearly. Right, me? So we understand one point very clearly. There is no point that even though object is very large in size, if it is very far, visual angle smaller, therefore respective image size at the retina smaller. Even though object is very close to eye, if the object is very smaller, visual angle is smaller, therefore image formed at the eye is also very smaller. Now let's say now you want to see this eye, you want to see this object at very far end, you want to see this object at very closer to eye, you want to see clearly. What is your solution? Tell me. Now you can't tell okay right okay what to do. The visual angle created by eye, the visual angle created by the sun and the bacteria is very small, therefore only very small image formed at my retina, therefore what to do, I can't see them, it's okay, you can't leave. Now you want to provide a solution, you want to do something, you should do something, and you want to see the object at very far as well as you want to see the object, very small object closer to you very clearly. You want to see them clearly. What will you do? Reply. What is the solution? If you want to see them clearly, what you want to do? Reply. I'm expecting responses from everyone. I'm expecting responses from everyone. Just right or wrong doesn't matter. Tell something. If you want to see them very clearly, very massive object at far, if you want to see it clearly, very small object at very closer to the eye, if you want to see it clearly, what's your solution? What will you do? What you want to do? Reply everyone. Reply everyone what you want to do. What you want to do. What you want to do. Right? Magnify the object. No, you want to, yeah, that happens only. You want to tell that point exactly. Right? I'm expecting that point exactly. The fact, what you want to do exactly. Very huge object at very far distance, if you want to see it clearly, and very small object closer to the eye, if you want to see clearly, what you want to do? What you want to do? Reply everyone. What you want to do? What you want to do? What you want to do? Use a microscope to observe, microscopic view, magnified view. No, I'm not getting the right answer. What you want to do? Using a microscope, telescope? No. What do you want to do? What is the fact? Definitely we know that. Definitely we know that we want to use the devices. But I'm asking what fact? I'm asking right. If you want to see them clearly, what you want to do? What is the change that you want to do? Right? Let's see. The change you want to do. Increase the visual angle. Exactly. Sir, increase the visual angle. Not increasing the magnification of the glass lens we use, increase the magnification of the glass lens we use. No, no, wrong. Increase the visual angle. Exactly. Right? To see objects we can't see naked. The use lens that makes the eye see them clearly. That is also no, no, wrong. Then adjusting the focal length. Only one for the right answer. Why, even though this massive object, why we saw it as small image? Even though it's a very massive, huge object, why we saw it as very small image at the retina? Right? This object is already small. Therefore, the image formed at the retina is very small. Because of what? Because of the visual angle is very small. Both of these objects formed very small visual angle at the retina. Because of that only, image formed the retina is very smaller. That's why we saw them small size. We saw them not clear. Sir, if we can increase such a way this visual angle, right? If we can increase this visual angle such a way, then definitely the image size, the image formed at the retina will be large. If we can form a larger image at the retina, so definitely we can see them clearly. Larger image formed at the retina means what? We see like large object. Then the solution is very clear. Solution is very clear. Somehow, if we want to see massive objects at very far from the eye, if we want to see very small objects closer to eye very clearly, the solution is increase the visual angle. Increase the visual angle. Okay. To increase the visual angle only, we are using some devices by using lenses. Those are what we call as optical instruments. Basically, what is the function of optical instruments? From the optical instruments, we are increasing the visual angle. Using some lenses, putting here and there, and we are increasing the visual angle. By increasing the visual angle, we are obtaining larger image sizes. Right? Using some lenses and optical instruments, we are increasing the visual angle and we are obtaining larger image size. That is the idea. Till now, everything is very clear, answer. Till now, everything is very clear, answer. Very clear. Learn properly. Learn properly. Right? Everyone don't explain everything properly, right? Learn properly, okay? Right. They're ready, done. Nice. We're taking a break at 9 and 10 o'clock, 7:30, 8, 9, 10 o'clock. Right. Okay. And now optical instruments, go to the tute, optical instruments idea. Optical instruments idea, okay. Optical instruments are designed to increase the visual angle. Highlight entire sentence. Optical instruments are designed to increase the visual angle. Highlight entire sentence. Two types of optical instruments are studied under this lens lesson, right? Two types of optical instruments are studied under this lesson. Number one, microscope, and number two, telescope. Okay, right, okay. Now the main topic is angular magnification. Angular magnification, right? Angular magnification idea. Okay, this is somewhat important story, right? Angular magnification, somewhat important story. I think all clear, nahi? By using the optical instruments, our aim is increasing the visual angle and obtaining enlarged images. That's our target. Increasing visual angles and obtaining enlarged images. That's our target. Right. Now, angular magnification. Previously, we talked about linear magnification means what? Image height over object height. If not, linear magnification means image distance over object distance, V over U. Now we are talking about angular magnification. Angular magnification. Now refer that note, angular magnification, refer the note. Angular magnification is the ratio of the angles obtained by the image at the eye. Angular magnification is the ratio of the angles obtained by the image at the eye when viewed through an optical instrument to the angles obtained by the object at the eye when viewed directly. Didn't understand me? It's okay. Then they have given a point that the magnification produced by an optical instrument, the magnification produced by an optical instrument is measured in terms of angular magnification rather than the linear magnification. Right? Now, linear magnification means we learned that linear magnification idea. Okay? Linear magnification means linear magnification means we learned that image distance over object distance. If not, image height over object height. So this is kind of a ratio between distances. Height is also a kind of distance. Nahi? Linear magnification is basically a ratio of distances. Now they are talking something about angular magnification. We have no idea about angular magnification clearly, but we know that now. After we read that sentence, we understood angular magnification means kind of a ratio of angles. Angular magnification means kind of ratio of angles. Currently, keep that idea in your mind. Angular magnification is kind of ratio of angles. I will explain the angular magnification after when I start explaining microscope stories. Right, rather than explaining roughly now, when I explain microscope story now today, I will slowly, by drawing the ray diagram, I will explain what is the angular magnification. Right? Ni? Okay, that story. Okay, now we can go to microscopes. Now we can go to microscopes, right? So angular magnification idea, I will explain bit later, right? Now currently keep in your mind linear magnification idea. From this idea, I am going to the microscopes. Now, entire lesson, optical instruments, we talk about microscope, telescopes. When it comes to microscopes, remember, we talk about two types of microscopes. One is we call as simple microscope. Other one is compound microscope. One is simple microscope. Other one is compound microscope. Right? Okay. So, microscopes. Microscope. First of all, tell me now, why do we use microscopes? In the beginning, I told you that I came to a conclusion to increase the visual angle and to obtain enlarged images only, we are using optical instruments. Specifically, microscopes are used to see objects which are very small and very close to the eye. Microscopes are used to see the objects which are very close and very small in size to the eye very clearly. Microscopes are used to see very small objects which are at very closer to the eye clearly. Okay. Then in this case also microscope increases the visual angle and microscope increases enlarged images. Microscope obtains enlarged images. That is the idea, right? Now I will explain now in that point under microscope, right? Microscope are used to form and view enlarged images of very small objects located closer to the eye. Microscopes are used to form and view enlarged images to obtain enlarged images of very small objects closer to the eye. Better you highlight, enlarged images. Okay, better you highlight uh, very small objects closer to eye. Microscopes we are using to obtain enlarged images by increasing the visual angle of the very small objects which are very close to the eye. Highlight small objects, very small objects closer to eye. They help magnify objects that are not clearly visible to naked eye, right? Angular magnification of a microscope. If not, we are calling it as magnifying power, angular magnification of a microscope. Right below, I have given a small space. Angular magnification of a microscope is defined as the, first of all, we'll write the definition. Then I will explain angular magnification now. Right, write down in that given lines, angular magnification of a microscope is defined as the, write down as the uh, ratio of angles obtained by the final image. Ratio of the angles obtained by the final image. Okay, give me 1 second, okay. Ratio of the angles obtained by the final image at the at the ratio of the angles obtained by the final image at the at the eye at the eye. Ratio of the angles obtained by the final image at the eye when viewed through the microscope. When viewed through the microscope. When viewed through the microscope. Ratio of the angles obtained by the final image at the eye when viewed through the microscope to the angles obtained at the naked eye. 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 Angles obtained at the naked eye Angles obtained at the naked eye by the object placed at the near point. 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 Placed at the near point. Okay. Right, ni? Okay. Okay. Okay, ni? Right. Okay. Now, now still you are not very clear about angular magnification. I will explain, don't worry. First of all, I will explain angular magnification for microscope. The idea is very simple. Anyhow, we are using a microscope to obtain enlarged images of the object. Because normally we are using microscope to see very small objects which are very closer to the eye. Therefore, we know our object is very smaller. We know our object is very smaller. Okay. From the microscope, what's our plan? Increasing the visual angle and obtain enlarged image. From the microscope, plan is obtain enlarged image. That's our plan. Okay. Right. Now, let's say now this is your eye. Very careful, listen. This story very important. Many confuse. This angular magnification idea, everyone confused and many don't understand. Okay, this is my eye. Naked eye means if without wearing any devices. If you are observing an object, then we say that you are observing that object with your naked eye. What is the dress for the eye? What is the dress for the eye? Spectacles, microscopes, telescope, they are the dresses for the eye. Naked eye means without wearing the dresses, if you look at the object. That means only with the eye. Only with the eye, if you are observing an object, then we tell that you are observing that object with your naked eye. If you are wearing kind of spectacle, if you are using kind of microscope or telescope, some optical instruments, and if you are looking at that object, then it is the naked eye. Do you understand? Now you are observing, now that's a very small object in front of your eye. You are observing that object using your naked eye, right? Naked eye. See the idea very clearly. Is your eye. Eye lens this object. You are seeing the object. It's a very small object only, but when I draw it, I don't draw a very small object. I draw a considerable size for the object. Okay, you understand? It's a very small object nearby your eye. Okay, very small object. Object is so. Right. Now then, if you are observing the object without wearing any optical instruments, any devices, then we tell that you are observing the object by the naked eye. Then angle subtended by the object when viewing the object with the naked eye, that is alpha. Angle subtended by the object, angle subtended by the object when you are viewing the object from the naked eye, that angle is we call it as alpha. Right? That is clear. That is clear. The respective image you can draw with respective image may be whatever. Okay. Okay. Right. That is not that much important. Okay, now we know that by naked eye, when you observe the very small object, we are not able to obtain an enlarged image, right? Therefore, we are using a microscope to obtain enlarged image, right? Somehow using the microscope, you obtain a kind of enlarged image because of this very small object. By using a microscope, some devices, you obtain an enlarged image. That final enlarged image, okay? Final enlarged image, right? If you consider same eye, same eye. Okay, same eye. Right? Is it okay? No, no. Same eye. Right, same eye. Right, now I'm drawing the final enlarged image of this object. I'm drawing the final enlarged image. Let's say the final enlarged image of this object is capital I. It's going to be very large than the object. Final enlarged image, that's going to be very large than object. Just think like this is the final. This is the final enlarged image. Angle subtended by the final enlarged image at the eye when you are observing through the microscope. Angle subtended by the final enlarged image at the eye when you are observing through the microscope. That is we call as alpha dash. Alpha dash. Right? Alpha dash. Okay? Right. Naked eye. Weaving through naked eye. Naked eye. Okay, naked eye. Naked eye. Naked eye, okay? Naked eye. Weaving through the microscope. Weaving through microscope. Weaving through microscope. 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 Right. Sir, now okay, now clear. Once again, sir, what is angular magnification? Okay, what is angular magnification? Before understanding about angular magnification, you want to understand two angles. One is alpha, alpha dash. You want to understand two angles like object distance, image distance. Like object height, image height, you want to identify two types of angles. One is alpha, other one is alpha dash. Normally, alpha belongs to object. Roughly keep in your mind. You can write down the stories. Normally, alpha belongs to object, alpha dash belongs to image. Like V belongs to image distance and U belongs to object distance. Alpha dash belongs to image, alpha belongs to object. Now, how they define angular magnification for a microscope is the ratio of alpha dash to alpha. Remember, angular magnification means remember the ratio of alpha dash to alpha. Angular magnification, that is what the ratio of alpha dash to alpha. It's an angle ratio, that is the angular magnification. That's why it's angular magnification. Distance ratio, that's why it's linear magnification. Linear. Length, linear. Angle ratio, that's why it's angular magnification. If I once again explain what is alpha dash? Alpha dash means remember final image. When you are observing by through that microscope, the final image, angles obtained by the final image at the eye. Right? What is the alpha dash? Angles obtained by the final image at the eye by the microscope. Angles obtained by the final image at the eye weaving through the microscope. That is alpha dash. What is alpha? Alpha means without any microscope, without any device, if you look at the object using your naked eye, if you look at the object using your naked eye, the angles obtained by the object is alpha. That is what we call as, this ratio is what we call as angular magnification. So remember, angular magnification means what? Alpha dash means what? Angles obtained by the final image. Alpha dash means what? Angles obtained by the final image, right? Angles obtained by the final image at the eye. Angular magnification means we all know that angle subtended, 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 angle subtended at the eye, at the eye. by the final image at the eye. Angle subtended at the eye by the final image. By whom? By final image, okay? Not just image. Because in the scenario, there can be one or two images formed in scenario. We always consider the final image. Angle subtended at the eye by final image. By final image, okay, important point, final image, final image, when you are weaving through the microscope. If not, when you are weaving through the microscope, okay, angle subtended by the final image by the microscope, okay, by the microscope, by microscope, by microscope. If not weaving through the microscope, weaving through the microscope, over, 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 angle subtended at the eye, same story, angle subtended at the eye, subtended at the eye, angle subtended at the naked eye, okay? Angle subtended at the naked eye, that is important, naked. Not just eye, at the naked eye. At the naked eye, by the object, by the object, by the object, by the object, see the idea, by the object, one important story is there. By the object, definitely, by the object placed at the near point, placed at the near point, placed at the near point, by the object placed at the near point. One important point is there. I will explain that story also once again. Placed, you must remember this equation. Placed at the near point. At near point. And now you might be wondering, sir, what is near point? Because optical ID fixed story, I will explain it later. At near point. At near point. Right. Now, how many of you know what's near point answer? How many of you can understand what's near point answer? Raise your hands. How many of you know? How many of you are aware about what is near point answer? Near point. Anyone? How many of you know what is near point answer? No one, right? Uh, Remember, now this story also I will explain. This story I will explain. Now, for a healthy eye, we defined 2 points, near point and far point. For a healthy eye, we define 2 points, near point and far point. The near point means, when I do ID fix, I will explain nicely. Near point means, remember now, when you keep an object, forget about this entire stories, only think about eye and the object. Now, do you think that if there is an object, do you think you are able to see this object at any locations of the object? Are you able to see the object very clearly, even though this object is at any location in front of the eye? No, right? Because we know that. Now, when you keep the object somewhere here, we are able to see this object very clearly, right? So our eye lens can nicely focus the object and we are able to see the object very clearly. But what will happen that when you bring the object very close to your eye, now you are looking at the object only, keep looking at the object only. When you are moving the object closer to your eye, closer to your eye, closer to your eye, after a certain distance, you see the object not very clearly. You see the object kind of blurred. And when you are looking at the object, you feel very tired. Your eyes are feeling very tired, right? So beyond a certain distance, when you are bringing the object closer to your eye, you can't see the object very clearly. You don't see the detail of the object very clearly. And also when you are observing the object, you feel like very tired, your eyes are. Also, when you are moving the object very far, when you're moving the object very far and when you're looking at the object also, if it's exceeding a certain point, then also you can't see the object very clearly. So near point and far point means, understand, roughly I will tell you, the minimum distance, the minimum distance of the object, the minimum distance of the object that you should keep an object in front of the eye. The minimum distance that you should keep an object in front of your eye to see the object very clearly without any tiredness for the eye. Without any tiredness for the eye, the minimum distance that you want to keep the object from the eye is what we call as what? What we call, that is the near point. Normally remember, for a healthy eye, near point is 25 centimeter. For a healthy eye, near point is roughly, remember, I will explain later. Near point for a healthy eye is how much? 25 centimeter. Near point for a healthy eye is 25 centimeter. And next story is far point. Far point means the maximum distance that the object is placed, but you should be able to clearly see the object. The maximum distance that gives very clear object without any tiredness for the eye. The maximum distance. That is what we call as far point. Far point, normally for a healthy eye, far point is infinity. Infinity means, don't you think it's 1 million meter? Not like that. Infinity means, remember, considerably that object is really far. The farthest distance that you can see. Normally for a healthy eye, far point is infinity. Far point is infinity for a healthy eye. Infinity. Infinity. Symbol is infinity. Actually, I was explaining the near point I was explaining the angular magnification. Angular magnification for a microscope. I told you angular magnification means basically a ratio of angles alpha dash to alpha. Now, alpha dash means for a microscope, alpha dash means very clear. Angle subtended at the eye by the final image when viewing through the microscope. Okay. In this scenario, eye is not naked because eye is viewing the image through the microscope. Therefore, eye is not naked in this scenario. Over angle subtended at the naked eye by the object placed at the near point. Right? Alpha means what? Alpha means you should look at the object from your naked eye, but remember, object must be exactly placed at near point of that eye. Object must be exactly placed at near point of the eye. That means 25 centimeter. This object must be placed at 25 centimeter. Near point symbol is capital D. Near point symbol is capital D. This object should be exactly at the near point. Near point, capital D, 25 centimeter from the eye. Right? From the eye, near point, object is at the near point. Right? Object is at the near point. Object is at the near point. Near point. Nice. That's it. Raise your hands. How many of you understood this angular magnification of a microscope? Angular magnification of a microscope idea, clear answer. Angular magnification of a microscope, clear answer. Generally, for a microscope, angular magnification is alpha dash over alpha. Alpha dash means angle subtended at the eye by the final image when viewing through the microscope. Over alpha means angle subtended at the eye by the object. Angle subtended at the naked eye. Naked eye by the object when the object is kept at the near point. That is the idea, right? Simple story. Now, what you want to do is in that tute you should write down in that tute after we writing the angular magnification idea. Okay. Now I have given a space, right? Page number 20. I have given a space to write down this idea, this diagram. Right, page number 20 space given to draw these two diagrams, everything. Page number 21, I have given a box. Page number 21, I have given a box. Under that box, this equation, angular magnification equation, this idea. And angular magnification equals alpha dash over alpha. Temporarily write down the story also. Temporarily somewhere else write down story also. quickly, quickly, quickly. Finish writing, answer. If you finish writing, answer. Right? If you finish writing, answer. Understand every point clearly. Angular magnification matters. Visual angle story important. Identifying everything. Angular magnification story also very important. Angular magnification idea is very important. Very important. Finish doing, raise your hands. Finish writing, raise your hands. Don't miss any single point. Write everything properly. Yeah? Don't miss any single point. Write everything properly. Finished, answer. Finished, answer. Finish writing, answer. Finished, answer. Finish writing, hands up. Angular magnification of a microscope. Angular magnification of a microscope story. Right? Angular magnification of a microscope story. I think everything is clear, ni? Right? Now, kind of comparison, linear magnification idea, angular magnification idea, comparison, this diagram story, ni? Alpha dash belongs to image, alpha belongs to the object, that idea, right? That story. Once you finish writing, raise your hands. Quickly, once you finish writing, raise your hands quickly. Quickly, quickly, quickly. Okay. Now what we do, angular magnification of a microscope. Angular magnification. Again, we are talking about two types of angular magnification. Right? Okay, sir, right. Linear magnification idea. Okay, understood. Angular magnification idea is also for a microscope. Angular magnification for a microscope. Okay. Angular magnification means alpha dash over alpha. Right. Final image. Final image. Right. Final image angle. Then over object angle, naked eye, near point. We had an idea about angular magnification for a microscope. Now we are talking about angular magnification for a microscope. Also, two types of angular magnifications are there. One is angular magnification for a microscope at normal adjustment, right? Other one is angular magnification of a microscope at abnormal adjustment. Normal adjustment, abnormal adjustment, different special adjustment, right? This is important. This is the only difficult part, right? What is the idea? Okay. Angular magnification of a microscope. Again, we can break into two stories. Angular magnification of a microscope at normal adjustment. Other one is angular magnification of a microscope at abnormal adjustment, if not special adjustment. What is the idea? Adjusting what now? By the name, we understand that we are adjusting someone's location. What do you think? Right? Normal adjustment, abnormal adjustment for a microscope. Normal adjustment, abnormal adjustment. right? Normal adjustment for a microscope. Normal adjustment. 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 Other one is abnormal adjustment, if not special adjustment. Abnormal adjustment, if not special adjustment. Near point. Other one is abnormal adjustment. Abnormal adjustment, if not special adjustment. Abnormal adjustment. That means special. Special, right? Special. Now I don't explain. I don't explain. Just you guys think. You guys think. Now roughly think. I think in the microscope now why we are using a microscope obtain a large image. Don't think about types of lenses, so number of lenses, so you don't think anything. You don't think anything. Only think about from the microscope we are obtaining final large enlarged image. Okay. Then what are we going to do? What is the adjustment that we are going to do from the microscope? Angular magnification, okay. Angles obtended at the eye by final image over angles obtended at the naked eye by the object placed at near point. This is fixed, right? Definitely alpha means what? Alpha means object must be at the near point. Object must be at the near point. Then you should look at the object from the naked eye. Then the angle is alpha. This is okay. Now you are going to adjust something. You are going to adjust something. I'm asking what are you going to adjust something based on your adjustment. Based on your adjustment, you call it as normal, abnormal. I'm asking. Yeah, I haven't explained properly. I'm asking your opinion. I want to know how many of you thinking properly, right? Just think what I am going to adjust. If we adjust someone, it becomes normal, abnormal. I am asking any idea about what are we going to adjust? Give some replies, please. Put some replies, everyone. In this scenario, I'm going to talk about angular magnification, two types, normal adjustment, abnormal adjustment. We want to adjust something. That means we are adjusting something. I'm asking, what are we going to adjust? Any idea? Just reply some. Let's see. What are we going to adjust? Reply. What are we going to adjust? Any idea? Give some ideas. Reply any ideas. Based on, now we are going to do a kind of small adjustment for someone. When we do that adjustment only, we are telling that some normal, abnormal story. Any idea what are we going to adjust? Any idea? Roughly, I'm asking. You don't want to know it. You can't know it also because I haven't taught you, right? But just I'm asking some ideas. What are we going to adjust? Give some replies. What are we going to adjust? Reply someone. Reply. I'm expecting some replies. What are we going to adjust? Okay, one answer is okay. The place where the final image is formed. Exactly. Right? The place where the final image is formed. We know that object alpha, object location is confirmed, fixed. Object is exactly at near point, if not 25 centimeter from the eye. But here, angle subtended at the eye by final image. The problem is still I haven't mentioned where is this final image exactly. Angles obtained by the final image at the eye, okay. Right? Angles obtained by the final image at the eye, okay. But I haven't specified where is this final image. Where are we going to form this final image? I haven't explained yet. We haven't specified where are we going to form the final image. Right? So what is the adjustment that we are going to do? We are going to adjust the location of the final image. Right? By using that microscope, we are doing something, and we are going to adjust the location of the final image. Now, so where are where are we going to locate the final image? We locate the final image at two different locations. Okay, we can locate the final image at the near point, that means 25 centimeter from the eye. If not, at the far point. At the far point, that means at the infinity. So we can locate the final image. We can locate the final image at the near point. At the near point, if not at the far point. If not at the far point. Near point, if not far point. Near point means 25 centimeter. Far point means infinity. Right? Far point infinity. Okay, very simple. Very simple. Angular magnification means we have the idea. Angular magnification of a microscope, very clear. Now I'm saying that based on the final image location, we talk about two types of angular magnification. Based on the final image location, we talk about two types of angular magnification. One is angular magnification of the microscope at normal adjustment. Other one is angular magnification of the microscope at abnormal special adjustment based on the location of the final image. I told you that final image can be located at the near point. If not, final image can be located at the far point. That is the rule. Final image can be located at the near point. If not, final image located at the far point. Now, what is normal? What is normal and abnormal scenario? Just think, basically, why are you using this microscope? So there is an object nearby my eye. There is a very small object. Now, very carefully listen. There is a very small object nearby my eye. Why I am using the microscope? By increase the visual angle, I am going to obtain a final enlarged image. What is normal? What is the normal story? Obtaining the final enlarged image, forming the final enlarged image is at the near point, at closer to your eye is normal, no? The final enlarged image is forming at infinity. Far point is normal. What is normal? Object is closer to my eye, obtaining the final image, forming the final image at closer to your eye. At the near point is normal, no? Forming that final image at farthest point is normal. What is normal? Hands up if you say, sir, since the object is very closer to your eye, forming the final image closer to your eye is normal. That means forming the final image at the near point is normal answer. Placing the final image, forming the final image at the far point is normal answer. Far point is normal answer. Oh God. Hands up who didn't understand answer. How many of you didn't understand answer? How many of you didn't understand answer? How many of you didn't understand answer? Okay. Right. Okay. One second. 1 second story. Understand means talk. It is very important story. Very difficult part. Angular magnification only. They are after easy. Right. Think practically. Think practically. Think practically. Is why. Your object is your object. Very small object close to your eye. I'm asking what is normal? What is normal? Creating this one's image, closer to the eye is normal low. Create this one's image closer to the eye is normal low. Creating this one's image far from the eye is normal. What is normal? Object closer to your eye. This object is closer to eye. Creating this object's image closer to the eye is normal low. Creating this object's image far from the eye is normal. This is far. This is close, near. I'm asking what is normal? What is the normal story? What is usual story? Raise your hand. Someone will say, sir, the normal story, the very normal, very common story is object is very closer to our eye. Therefore, forming this one's image closer to our eye is normal answer. Forming, sir, this object is closer to my eye. Forming this object's image far from the eye is normal answer. Remember, if your object is closer to your eye, creating its image is closer to your eye is the normal one. Normal. It's normal. Normal, right? If the object is closer to your eye, creating its image is closer to your eye is normal. When someone is creating closer object, when someone is creating, now object is closer to the eye, someone is creating its image far from the eye means abnormal. It's not normal, abnormal. Normal adjustment means remember, image, final image is where? At the near point. For a microscope, normal adjustment means remember, final image is at the near point. Right? Final image at the near point. Under normal microscope, under normal adjustment, remember, final image at the near point. Final image at the near point. Final image where? At the near point. At the near point, that means 25 centimeter. At the near point. Near point means the closest distance. 25 centimeter. 25 centimeter. Remember, if the microscope is under abnormal adjustment means remember, final image of the object is at the far point, at the infinity. Right? Final image at the infinity. Final image at the far point, at the infinity. Final image where? At the far point. At the far point, that means infinity. So when you do questions, you will understand more, but you have an idea. You should have an idea, right? Right. And now what we can do, we can modify the angular magnification based on the normal adjustment and based on the abnormal adjustment. Right? Suppose if they have mentioned in the question, a microscope is at the normal adjustment. A microscope is at the normal adjustment. Remember, angular magnification equals, angular magnification equals, right, equals angle subtended at the eye by the final image at the near point. Only term is at the near location. Only difference is based on normal or abnormal, only adding is the location of the final image. That's it. So what we can write down? Angle subtended at the eye by angle subtended at the eye by. It's a difficult story. The difficult story is on this one. At the eye by. At the eye by final image where? By final image where? Final image at the near point. By final image. Where is the final image? Under normal adjustment, near point. Final image is at the near point. 25 centimeter. Right? At the near point. Okay. At the near point. At the near point. At the near point. At 80, yeah? At the near point. Okay, at the near point. At near point. That means 25 centimeter at near point. Only on based on the adjustment, there is a small word enter into this equation. That's it. Based on the adjustment, a small word is entered into this equation which specifies the location of the final image. At near point by microscope. Nothing, no, same equation, only it specifies the location of the final image. This is the general equation which is not specifying the location of the final image. But if you talk about normal abnormal stories, it is specifying the location of the final image. That's it. Very small, very simple story. I am only unnecessarily I'm explaining actually. I'm explaining some stories. That's the problem. By microscope. By microscope. By microscope over over. This is no different. Same story. No different. Same story. No different. Alpha same story. Angle subtended at the naked eye by the object placed at the near point. No different. Same story. Angle subtended subtended at the eye. At naked eye. Okay, every time I forget this naked story. Naked, no dress. Naked, no dress. Naked, no dress. Naked eye. Naked eye. Okay, not just eye. It's naked eye. No dress. Eye is not wearing a dress. By the object. By the object. Uh, placed at the near point. Placed at the near point. Placed. You also need to write the equation. These different colors. Use different colors. Okay, don't just write simple color. Placed at near point because these are the important points. MCQs they have tested many times these stories at near point. At near point. At near point. At near point. Then tell me the if the microscope is at abnormal adjustment, final image is at the far point infinity. If you write the angular magnification for this scenario accordingly, right? Angular magnification, write it. Angular magnification going to be angular magnification, same story. Angle subtended at the eye by final image where at the far point, at the infinity by microscope. Remaining is same. Same story. Same story. Same story. Angle subtended at the eye. Yes. Yes, ne. Now okay, ne? Uh, Now it's okay, right? Can someone put a small message? Now it's okay. Okay, right? Okay. Wait 1 second. Okay, nice, ne? Nice story. Nice, ne? Okay. Charge went down. Okay, right. Okay, actually, I was giving a small summary only. I think all clear, right? 1 second, I'll give a small summary. Small summary because it's important. Understanding angular magnification, that story is very important. Now, if I give a small summary, uh, we are talking about microscopes, right? So, why are we using microscopes? To see clearly small objects nearby our eye. Then, what are we going to do from the microscope? We are going to increase the visual angle and we are going to obtain enlarged final image from the microscope. We are going to obtain enlarged final image from the microscope of that very small object. Right? Okay. Then very small object nearby the object, we are going to obtain enlarged final image of that object from the microscope. Okay. Then linear magnification means we mentioned that it's a kind of angle ratio. Alpha, sorry, angular magnification means kind of angle ratio alpha dash to alpha. Normally keep in your mind alpha dash means angle subtended by final image. Alpha means angle subtended by the object. Only explaining like that is not sufficient. We want to specify. Alpha dash means what? Angle subtended at the eye by the final image when viewing through the microscope. What is alpha? Alpha means angle subtended at the naked eye by the object when the object is placed at near point. That is okay. That is the angular magnification idea. But based on the location of the final image. Normally, when we are using a microscope, we locate the final image based on the condition at two different locations. Some scenarios we locate the final image at the near point. Some scenarios we locate the final image at the infinity far point. What is normal adjustment? Normal adjustment, if you can locate the final image at the near point. Why? Because we are observing object, small object closer to our eye. Therefore, if you can locate the final image at the near point, that is the normal. That is a normal story. If you can locate the final image at the far point infinity, that is abnormal. So in the exam, if they ask you to modify the angular magnification of a microscope for a normal adjustment, angular magnification of a microscope for an abnormal adjustment, only difference is specify the location of the final image. Right? Everything is same. If they ask you to find the, if they ask you to explain the angular magnification of the microscope at normal adjustment, we know at the normal adjustment, final image is at the near point, final image at near point. When the microscope is at abnormal adjustment, we know that final image is at the far point. Only specify the location, that's it. This idea crystal clear answer. This idea very clear answer. This idea very clear answer. It's very clear. Very clear answer. I think I explained the idea properly. Now you want to write down. You want to write down in the tube page number. In the tube page number, you should write down in the tube page number. Okay, page number. Rightly. Page number 21, a note. Angular magnification does not have units or dimensions. Highlight that point also. Angular magnification does not have units or dimensions. Angle, low angle, no units, no dimensions. Then adjustment of a microscope. The topic. Read the topic. Adjustment of a microscope. The final image formed by a microscope can be positioned at various positions from least distance of distinction to infinity. That means near point to far point, right? The final image formed by a microscope can be positioned at various positions from near point to far point. Near point is what we call as least distance of distinction. Far point is infinity. Thus, there are two main adjustments for a microscope. Number one, write down. Number one, write down. Number one, write down. Normal adjustment of a microscope. Number one, normal adjustment of a microscope. Number two, abnormal adjustment of a microscope inside the bracket, special adjustment, close the bracket. Abnormal adjustment of a microscope inside the bracket, special adjustment, close the bracket. Right? That idea also clear. Now, under normal adjustment, I have given some space. Under normal adjustment of a microscope. Under normal adjustment, I have given two lines. In that lines, write down. Right, page number 21. Under normal adjustment, I have given two empty lines. Write down this idea. Write down. If the final image formed by the microscope, if the final image formed by the microscope is adjusted so that it lies at the least distance of distinction. It lies at the least distance of distinction. It lies at the least distance of distinction. Inside the bracket, 25 centimeter, 25 centimeter. Inside the bracket, near point. Inside the bracket, near point. Put hyphen and write down 25 centimeter for a normal line. Near point, hyphen 25 centimeter for a normal line. Close the bracket. Okay. Then in the tube, angular magnification of microscope at normal adjustment. Another topic. Angular magnification of microscope at normal adjustment. This idea. This one, this equation right on there. This one, this equation right on there. Okay. Finish writing, hands up. Once you finish writing, raise your hands. 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 Raise your hands. Then visual angle story clear. Angular magnification idea is very clear. Normal adjustment, abnormal adjustment idea very clear. Have a good idea now. Took time and explain. Have a good idea now. Have a good idea, then easy. Finished, answer. Once you finish writing, raise your hands. Once you finish writing, raise your hands. Raise your hands. Nicely. Nice story, nice. Nice story, nice. Hands up, finished, hands up. Nicely done. Done, story done, story done. Okay. And now under abnormal adjustment, page number 22, abnormal adjustment. There are two lines I have given write down. Abnormal adjustment. If not special adjustment, write down there. Write down there. If the final image formed by the microscope, if the final image formed by the microscope, if the final image formed by the microscope, if the final image formed by the microscope is adjusted so that is adjusted so that it lies at the infinity. It lies at the infinity. It lies at the infinity inside the bracket far point. Adjusted so that it lies at the infinity inside the bracket far point, close the bracket. Okay, when the topic is angular magnification of microscope at abnormal adjustment, then this story write down in the given box. In the given box, story write down there. Write down there that story. Okay, okay. And now we can talk about microscopes. Finish writing, hands up. Once you finish, raise your hands. Once you finish, raise your hands. Once you are done, raise your hands. Once you are done. Finish writing, raise your hands. Okay. Now microscopes are divided into two types. One is simple microscope. Number one, write down there. Simple microscope. Number two, write down compound microscope. Right. Then we'll talk about simple microscope. Simple microscope is, remember, a simple microscope consists of a single converging lens with a relatively short focal length. Highlight. A simple microscope consists of a single converging lens with a relatively short focal length. Highlight single converging lens, convex lens. Highlight a short focal length. That's story. Now we'll talk about simple microscope. Very simple. Very simple. Very simple idea hereafter. Very easy, not difficult. Very easy. Very easy hereafter. Right. Simple. Now story. Okay. Now story. 10 o'clock, we have 2 hours roughly. We have 2 hours roughly. If we finish microscope and right. Now, simple microscope is, remember that in Sinhala we are calling magnifying lens, atkache. That is what we call as a simple microscope, right? Simple microscope consists a convex lens having a smaller focal length. This consisting a convex lens having a smaller focal length, a simple microscope idea, right? Simple microscope. Microscope. Simple microscope. Are you facing any issues? Someone respond. If you are facing an issue, someone respond. Any issues you are facing? What are the two microscope? Simple microscope. Other one is compound microscope. Issue you are facing? Are you facing issues? All good, right? If you're facing any issues, put some messages. Okay. If you're facing issues, put some messages. Okay. Right. Okay. Now, simple microscopes. Remember, the single convex lens is what we call as simple microscope. The magnifying glass, if not in single, we are calling it as atkache. I don't know in Tamil, I think Buddha Kannadi. I don't know the Tamil word. I think it's Buddha Kannadi or something. I don't know. Right? Okay. Now, if I draw a simple microscope, right? If I draw simple microscope, see the idea. So you also should draw this diagram. But first of all, I will explain. Listen very carefully, every point. Be very careful. It's a basic idea, right? Simple microscope at the normal adjustment, okay? At the normal adjustment. Simple microscope is at the normal adjustment. Right now, you know what is the normal adjustment means, you know. Normal adjustment. Right? Okay. Then story. Okay. Then story. First of all, listen because you don't know what size of image you want to draw with me. First of all, listen carefully. Right. Then if I draw the convex lens, single one convex lens. If I draw one convex lens, it's vertical. Okay. Right shape. If I draw the convex lens, right. This convex lens is made with glass. Right. Also consider now this convex lens has two curved surfaces and think like both the curved surfaces are identical. Focal length of this convex lens is, let's take it as simple if it's a fixed value. Focal length of this convex lens is simple if, that is simple if it's a fixed value, right? Okay. Okay, Ni. What's my ultimate goal? My ultimate goal is when my object near to the eye, very small object near to the eye, I want to obtain enlarged image. That's my target. So by using a simple microscope, my goal is the smaller object closer to the eye, I want to obtain the very large image, right? Now you are keeping, let's say now you are keeping the object in front of the simple microscope. You are keeping the object in front of the convex lens. I say my object as, this is my object. My object. Be careful, listen. Is the object. Okay. Now, okay, right, sir. Now, this is the simple microscope. How many of you have used that Atkache Budakannadi magnifying lens hands up in your childhood? How many of you have used that Atkache, if not magnifying lens, if not Budakannadi, that hands up? Raise your hands. How many of you used that story hands up? So we all have used that story. Ni. Then mostly I think you may have used that magnifying lens. I don't know what we call in English. In English, are we calling a magnifying lens? Someone reply. What is the word that we call in English for Atkache? Magnifying lens, right? Okay. Then just imagine how you observed large images. So what you have done is mostly I know you used that magnifying lens to enlarge the letters in your school notebook, right? Then what you do? You keep the lens nearby your eye. You keep the magnifying lens nearby your eye, almost closer. So you don't keep like this and you don't look at the, you don't keep your eye somewhere here and you don't keep the magnifying lens somewhere here and you don't look through the magnifying lens. Most of the time what you do, like the Sherlock Holmes stories also, what they do, you keep the magnifying lens nearby your eye. You keep the magnifying lens nearby your eye and through the magnifying lens you observe the object, right? If it is a book, there's a book. The letters A, B, C, D, whatever. There are letters. This is the magnifying lens. This is why you are keeping your eye closer to the magnifying lens. When you look through the magnifying lens, you see larger letters. Larger letters. That's the idea. Nahi? So you want to understand in here very important point. Many don't understand. Location of the eye and location of the object are at same location, think like that. Since almost magnifying lens is closer to your eye, think location of your eye and location of your magnifying lens, this convex lens are at same location, right? Okay, that story. If I tell that object distance from the convex lens is 5 centimeter, the distance to the eye from the object is also 5 centimeter. That story important. Okay. Next story is see the idea. Next story is now I'm talking about your experience. Okay, I'm experience idea using your experience. Now your book is somewhere here, right? Your book is exactly now without using the magnifying lens. When you look at the book, without using magnifying lens, when you look at the book, yeah, book is somewhere here. Book is somewhere here. Book is somewhere here. Now you are without using the magnifying lens, you are looking the book. Letters are very small and you can't read the letters. Therefore, you are using the magnifying lens. When you're looking through the magnifying lens, now you can see the letters, large letters you can see. Before using the magnifying lens, your letters were on the book. Letters were this level, right? Small letters. Once you use the magnifying lens and once you refer the letters, larger letters, exactly where? Exactly where those letters are formed. Raise your hands how many of you say letters will be formed at the same location of the book and I don't know how many of you get what I'm telling, but if you don't understand, I will explain once again, right? So letters A, B, C, D on the book. Letters are on the book. Letters are on the book, right? This is the object. Book with the letters are object. Book with the letters are object. Right? Earlier, this is your eye location. This is your eye position. Earlier. Right? So when you are looking in the book, start reading the letters, the gap was actually, for an example, just think 10 centimeter, okay, 25 centimeter something, for example, 25. Okay, then you see small letters, small size. Okay, then what you use a magnifying lens. When you're using a magnifying lens and when you're looking the book, raise your hands. How many of you feel like now the gap between your eye and the book is high? And how many of you felt experience? I'm asking you experience. Once you are referring the book letters using a magnifying lens, you get large letters. Okay. Once you are referring the book with the magnifying lens, how many of you feel like now the gap between your eye and the book is large and the gap is high, the gap is low and the gap is low and the gap is low. Really? Actually, the gap is high. Large letters. Once you're referring through the magnifying lens, gap is high. How many of you understand what I'm talking, answer? How many of you understand I'm talking, answer? Guys, do you understand I'm talking? Okay. Okay, very simple. Okay, very simple. Normal adjustment. Okay. Now there's an object, right? This is my microscope consisting only one convex lens. Okay. Now I place this very small object in front of the convex lens. I'm going to obtain enlarged final image. So in that case, what we do, we keep the object in between focal point and optical center. In that case, we place the object exactly between the focal point and optical center. Then we know the characteristics of image if you keep the object between focal point and optical center. Right? In that case, we know that enlarged virtual upright image will be formed behind the object. That's what we learned. Okay. If you do the ray diagram, light ray passing through the optical center. If I draw only two standard rays emitting from the topmost point of the object, the light ray passing through the optical center does not refract. Okay. Second standard rays, the light ray parallel to the principal axis. After refraction, passes through the focal point. The light ray parallel to the principal axis after refraction from the convex lens passes through the focal point. Passes through the focal point. I mark the focal point somewhere here, something. Passes through the focal point. Okay. Passes through the focal point. Okay. Okay. So very clear that I have drawn to stand right rays emitting from the topmost point of the object. Then we know that these light rays will never converge somewhere here in this region. More and more, they will diverge only. They were spreading out only. When you extend these two light rays backward direction, if you extend these two light rays backward direction, backward direction, right? They seem like converging exactly here. Therefore, explain that there will be a kind of virtual image formed behind the object. This story we know. This idea we know. Right? Now draw the diagram under the normal adjustment of a simple microscope. And now draw the diagram. The diagram in the given space. This diagram, draw it. This diagram, draw it. The image will be what? Virtual upright image. The image is capital I. The image is capital I. Capital I image. Capital I image. Okay, very simple. This is the simple microscope story. It consists only one. It consists only one lens. Now I'm currently talking about simple microscope at normal adjustment. Now tell me, when the microscope is a normal adjustment, where is the final image? Reply everyone. If the microscope is a normal adjustment, where should be the final image? Reply everyone. Where should be the final image? Reply everyone. Reply everyone. Where should be the final image? Reply everyone. Reply everyone. If this simple microscope is a normal adjustment, where should be the final image? Reply everyone. Reply everyone. Near point. Near point. Near point means if you measure the distance from optical center to image, the image distance, final image, there is only one image formed in the scenario. Therefore, final image is also this one only. The distance to the image from the optical center is equal to the near point. That means 25 centimeter. That means 25 centimeter. Right? This gap is how much? This gap is how much? That is the near point. The image distance how much? That is the near point. Capital V is how much? Simple D, near point. That is 25 centimeter. That is 25 centimeter. Right? 25 centimeter. Okay. Now object distance, let's take it as U. Object distance, let's take it as U. Object distance U. The distance measured from optical center to the object is object distance. That is U. That is U. Right? Okay. I told you where is your eye. I told you, remember, eye and magnifying lens both at same location. If you mark your eye, you can mark your eye like this. Okay. Now I'm marking the eye like this. Okay, I can mark the eye like this also. But remember, eye is almost closer to the convex lens. Eye is almost closer to the convex lens. Here is your eye. Okay, I can mark like this, but I am marking like this also. It's possible. Understand, if I mark like this, don't you misunderstand. There is a gap between eye and the lens. Don't think like that. Okay? Okay, mark the eye location also. If I mark the eye location, I mark like this. It's our eye. It's our beautiful eye. Okay. Write me. This story write. This story write down. Okay. Write down. Okay. That's okay. That is okay. Now please write down here. Write down here. Final image formed by the microscope. This one. Write down this one. Final image formed by the microscope. Write down everyone. Everyone write down. Okay. Hands up. Finish drawing. Hands up. Raise your hands. Finish drawing. Hands up. Finish drawing. Hands up. Still drawing. Hands up. Still drawing. Still drawing. Hands up. Still drawing hands up. Still drawing hands up. Raise your hands. How many of you finished drawing hands up? Okay. Then mention that here final image formed by the microscope. Arrow, final image formed by the microscope. Right, me? Okay. And now, shall we find the angular magnification for the scenario? Angular magnification. Right? Okay. Angular magnification means we can remember, sir, that is alpha dash over alpha. Angular magnification means that is alpha dash over alpha. Alpha dash means we can remember angle subtended by the final image. In this scenario, this is the object, this is the final image, angle subtended by the final image at the eye. Eye is here. Now very clear that this eye is not naked. This eye is wearing a dress. The dress is simple microscope. This eye is not naked. This eye is wearing a dress. The dress is the simple microscope. Then alpha dash, if you can remember, alpha dash means angle subtended by the final image, final image at the eye through the microscope. When viewing through the microscope, angle subtended by the final image at the eye. Then remember, this is your alpha dash. Then remember, this angle. This angle is your alpha dash. Alpha dash. Okay. Alpha dash. Right, ni? Alpha dash. Let's consider object distance as h naught and let's consider object height as h naught and image height as hi. Right? Just consider object height is h naught. Consider object height is h naught. Image height is hi. Hi. Okay, that story. Okay, that's going to keep in your mind. Next story is what is alpha? Alpha means we know that, sir, if you bring the object at the near point of the eye, when you are observing that object at the near point through the naked eye, then angle subtended by the object at the eye is alpha. Again, what is alpha? If I draw the eye, sir, alpha means if you draw the eye, alpha means what? Alpha means bring this object through the naked eye, bring this object and place it near point to the eye. If I place this object near point to the eye, near point, same object. If you keep the object at the near point of the eye, that is simple D. Near point is simple D. Simple D from the eye. The angle subtended by the object at the eye is alpha. Angle subtended by the object at the eye is alpha. This angle is how much? This angle is alpha. Right? Okay. Okay, clear. Clear. I know what is alpha dash. I know what is alpha. Clear? Right. Okay. Okay. Object height is how much? Object height is h naught. Object height h naught. H naught. Right. Okay. Finish writing till here. If you draw these two diagrams in under that topic, draw those two diagrams under that topic. Topic is what? Normal adjustment of a simple microscope. These two diagrams. H naught, capital D alpha, hi, H naught, alpha dash, V equals D, U story, and focal length simple length. Finish writing answer. Once you finish writing, raise your hands. Once you finish, raise your hands. Once you are done, raise your hands. Once you are done, raise your hands. Raise your hands. If you finish, raise your hands. You can mention here near point, okay? You can mention near point. Location is near point. Location of the final limit is near point. We can mention them. Right? Finish drawing, hands up. Once it is drawing, hands up. Nice story. Finished, hands up. Finished, hands up. Finished, hands up. Okay. Now we'll talk about expressions for angular magnification. In exams, they ask you, especially now, all the previous derivations in optics, they don't ask in your exam. Right, even now, last week also we derived how this lens equation came, 1 over v minus 1 over u equals 1 over f, how the lens equation came also, we derived. Normally exams, they don't ask the derivations, but hereafter, optical instruments, the derivation of angular magnification stories, they ask in your exam. Mostly, the first Roman number 1, Roman number 2 parts are derive the angular magnification for simple microscope and normal adjustment. Derive angular magnification for simple microscope and abnormal adjustment. Therefore, they ask the derivations in your A-level exam. They have asked all the previous papers. Just check, go and check. They ask the derivation. Therefore, you want to understand how to derive this idea properly. Properly. Angular magnification idea. Very careful listen. Angular magnification idea. Right. So we know that angular magnification that is equal to alpha dash over alpha. Angular magnification. That means I can take it as capital M, right? Linear magnification also we represent by capital M. Angular magnification also we are represented by capital M only. That is equal to alpha dash over alpha. Very careful in the derivation. Capital M equals alpha dash over alpha. Remember normally this alpha dash angle, since this object is very small, right? Since the object is very small, normally remember this alpha dash alpha angles are very small. Normally, alpha dash alpha angles are very small, right? Remember, normally alpha dash alpha angles are very small. Therefore, what we do, since alpha dash alpha are very small angles, very small angles, we can consider their tan values. Considering their tan values, okay, that they are tan value of those angles equal to the angle when the angles are very small, right? Alpha dash very small means alpha dash approximately equals tan alpha dash. If your alpha angle is very small, that alpha angle is equal to approximately tan alpha, right? So we can do something like this. Since alpha dash alpha are very small angles, their tan values equal to those angles, right? Angles equal to their tan values. Angles equal to their tan values. Their tan values. That means we know that. That means alpha dash approximately almost equal to tan alpha dash. Alpha angle is approximately equal to tan alpha value. Therefore, we can write down angular magnification capital M. We can write down capital M means what? Capital M equals alpha dash means tan alpha dash over alpha means tan alpha. Tan alpha. I take it as equation 1 or something, equation 1 or Roman number 1 or whatever. Roman number 1. Roman number 1. Okay. Now tan alpha dash. Tan alpha dash means we know that from this diagram. from this diagram, tan alpha dash means what? Tan alpha dash means what? Tan alpha dash. What shall I do? I can tell tan alpha dash means this larger right angle triangle. See this larger right angle triangle? Look at it. Look at my finger. Larger right angle triangle. A tan alpha dash means opposite is HI, adjacent is V, that is D. Tan alpha dash means HI over D, right? But once again, roughly I will draw the diagram somewhere here also for your understanding. For your understanding, roughly I will draw the diagram also. No need to do it, but roughly I'm drawing. Roughly I'm drawing. Okay, roughly I'm drawing. Roughly I'm drawing this idea. Image is HI ni. Image is HI. HI. And then the light ray coming from the image. Light ray coming from the image. Okay. Then write that idea. Okay. And then the object. I don't want to draw the object also. I don't want to draw the object also, alpha dash. Alpha dash. And the convex lens. And the convex lens. This gap is how much? This gap is simple D. This gap is simple D. This gap is simple D. V equals simple D. V equals simple D. Right? Then we know that tan alpha dash means we know tan alpha dash means we all know that that is equal to opposite over adjacent. HI over D ni. HI over D. HI over D. HI over D. Right ni? HI over D, that is going to be how much? That is going to be HI over D is how much? HI over D. Right? HI over D. Okay ni? Right, that is going to be something, some story. Likewise, tan alpha. Tan alpha going to be, if you consider the scenario, tan alpha means what? Opposite is HO, object height, adjacent is distance near point capital D. Likewise, I can write down tan alpha means what? Tan alpha means I can write down tan alpha equals what? HO over D. Ni. HO over D. Therefore, I can write down from equation 1, Roman number 1, I can write down angular magnification capital M equals what? Angular magnification capital M equals what? That is going to be equal to tan alpha means what? HI over D. HI over D. HI over capital D over tan alpha means what? HO over D. HO over D. Right? Now we understand capital D cancel out. Capital D cancel out. Angular magnification becomes exactly equal to what? Angular magnification becomes exactly equal to HI over H naught. What do we mean by HI over H naught? So that is the linear magnification. HI over H naught means linear magnification. So now, actually, I was finding angular magnification. When I was finding angular magnification, I found that angular magnification of the simple microscope at normal adjustment exactly equals to the linear magnification. Right? Right? Therefore, angular magnification equals HI over H naught. Till here, clear answer. Till here, clear answer. Till here, clear answer. Till here, clear answer. Clear ni? HI over H naught means this angular magnification is linear magnification. Linear magni. So in this scenario, we understand angular magnification exactly equals to linear magnification. Not always, some scenarios only. Angular magnification, angular mag, right. Right, still I haven't derived the equation for angular magnification for a simple microscope at normal adjustment. Hereafter what we do, we apply Lenz's equation. Hereafter what we do, we apply Lenz's equation. Right? Hereafter what we do, we apply Lenz's equation. Right? We are applying Lenz's equation hereafter. First of all, uh, you also the under that topic, under the topic, right? The under the topic, topic is what? Normal adjustment for simple microscope, expression for angular magnification. You write this entire story and stops here. Stop here. Once you finish writing here, raise your hands. Right? Come here. Once you finish writing, raise your hands. Once you come here, raise your hands. Right? Come here, then raise your hands. Come here, then raise your hands. Then raise your hands. Then raise your hands once you finish writing. Draw the location of the object also, no issue. Here, this diagram. Mark the object location also. Object height is HI. Object height is HO. Object height. Just mark this point is point capital A, point capital B, right? This is the object O, image capital I. This point is point capital A. Point capital A, right? Likewise, mark those stories. This is point capital B something. Mark them. This is the diagram. For us to understand simply, I drew the small story here, right? Tan alpha means you consider AIP. This is point capital P. AIP triangle. AIP triangle. Tan alpha idea came from this diagram. Huh? Tan alpha idea came from this diagram. Finished writing answer. Once you finish writing, raise your hands. Finish the answer. Okay, ni? Right, okay. Okay, ni? Right. Okay. So now angular magnification equals image height to object height. Image height to object height. That means what? Image height to object height means that is the linear magnification. Image height to object height. That means what? Image distance to object distance. That means image distance to object distance. Right? That means image distance to object distance. We can write down hi to h naught. If not, we know that v over d, v over d. If not, we can write down v over d. We can write down v over d. Okay, ni? Capital M equals hi to h naught. If not, v over d equals v over d. V over d. Right, ni? Angular magnification equals v over d. Just take it as equation. Just take it as it has Roman number 2 something. Okay, write down. After that, red color pen write down. Red color pen there, write down. Red color pen write down there. When the simple microscope is at normal adjustment, when the simple microscope is at normal adjustment, when the simple microscope is at normal adjustment, its angular magnification equals to linear magnification. When the simple microscope is at normal adjustment, angular magnification equals to the linear magnification. Angular magnification equals to linear magnification. Linear magnification. Right, me? Right. Okay. Now what you do now, okay, now this story Roman number 2. Roman number 2, now lens equation. Roman number 2, lens equation. Lens equation. Apply lens equation for this scenario. Object is here. Object distance u. Image is here. Image distance is v equals d. If you apply lens equation, focal length is simple length. Apply lens equation. When you apply lens equation, lens equation 1 over v minus 1 over u must be equal to 1 over f. Right? 1 over v minus 1 over u must be equal to 1 over f. Sign convention. Sign convention. Direction of light is right side direction. Object distance and image distance both are in the opposite direction of light. Therefore, u and v signs are positive. But focal length sign is negative. Why? Convex lens have negative sign. Okay. 1 over v minus 1 over u equals minus 1 over f. Okay. I thought because I want to involve. Now I realized that angular magnification is linear magnification. Therefore, in this lens equation, I want to involve linear magnification. Why? Linear magnification is angular magnification. I want to involve linear magnification. Therefore, I thought of multiplying by v. Since I know the image distance is exactly the near point capital D, I thought of multiplying everyone by capital D. If I multiply everyone by capital D, I know that capital D over V minus capital D over U. D over U must be equal to minus D over F. Almost done. Sir, D over V. Look here. D over V. Okay, I thought of multiplying by V. Okay. Image distance V. I thought of multiplying all the terms by image distance V. V over V, V over U minus V over F. V over V means what? 1. 1 minus image distance is what? In this scenario, image distance is what? That is the capital D, near point. So therefore, we can write down V as capital D. Capital D over U. Capital D over U must be equal to minus image distance is V is what? V equals exactly D. D over F. D over F. D over F. Almost done. Right? D over U means what? D over U. Right? Okay. Yes. Okay. Right? If I multiply everyone by V, D over U ni. Okay, D over V. I made a mistake ni here ni. Yeah, I made a mistake here. If I do a mistake, tell me, okay? Image height to object height ni. Image height means image distance V, that is D. Image distance is V, that is D. Object distance is what? U. Object distance U. D over U here. Right? A D over U means what? Roman number 2, that is the linear magnification, if not angular magnification. D over U is what? Linear magnification, if not angular magnification. Therefore, I can write on here D over U means angular magnification. Angular magnification. I come from here to here. Therefore, finally, 1 minus angular magnification, if not linear magnification, capital M, in this scenario only, equals minus capital D over F finally. Subject capital M minus capital M right side, minus D over F left side. So when you subject capital M, finally I'm getting the angular magnification of simple microscope at normal adjustment is exactly how much? Capital D over F plus 1. Capital D over F plus 1, you must remember. You must remember capital D over F plus 1. You must remember this equation. It's a must story. Must story. Remember, in a simple microscope is a normal adjustment, angular magnification equation going to be capital D over F plus 1. It's a must equation. Must equation. Very important equation. Very, very important equation. Write down till there. Write down till there. Write down till there. Finish writing answer. Also understand some important points. Now you write down with your own words, okay? I is always closer to the simple microscope. Therefore, there is no gap between I and the microscope. That point. Okay. In this scenario, remember. Now write down also. Write down a point also. Finish writing answer. If you finish writing answer, stay focused and learn. I calmly, slowly explain everything properly. Get the maximum benefit. Right? You guys get the maximum benefit. Finish writing, raise your hands. Okay. You can use the entire given space you can occupy. You can occupy that expression for the angular magnification, entire space you can occupy. Right? Okay. Almost done. Then we'll talk about simple microscope and abnormal adjustment. Some stories. Finish writing answer. Very simple. You must remember this idea. The important point in a simple microscope and normal adjustment, angular magnification equals linear magnification, that idea. Right, write down now normally. If you are now see the idea. Now, if the simple microscope is a normal adjustment, where is the object? Object must be in between optical center and focal point. Where must be the image? Image must be exactly at the near point, least distance of distinction, if not 25 centimeter. Somewhere else write down when the simple microscope is at normal adjustment. When the simple microscope is at normal adjustment. When the simple microscope is at normal adjustment, object must be in between optical center and focal point. Object must be in between optical center and focal point. Object must be in between optical center and focal point. And the final image must be exactly at the least distance of distinction, if not near point. Final image must be exactly at the least distance of distinction, if not near point. 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 Right? If not near point. Okay. Right. Okay. Okay. Whatever the theories I explained regarding simple microscope and normal adjustment, very clear answer. The theories I explained till now, everything is very clear answer. The theories I explained regarding simple microscope and normal adjustment, very clear answer. Very clear. Very clear. Okay. Right. Now, hereafter, I thought of, now I'm not asking hereafter, raise your hands. Okay. People don't respond. People don't respond. Therefore, I thought of hereafter, I'm not going to ask hereafter, raise your hands. Okay. I'm keep on explaining one, yeah? No issue, ni? No issue, right? Hereafter, what I do, no point of asking, raise your hands and checking the majority understood or not. And if not, once again, explaining is no important, not important, right? Therefore, I'm not asking hereafter, raise your hand story. Okay, I keep on explaining. I don't mind whether you understood or not. Okay, we'll do in that way. That's nice. Even you guys can't raise your hands, right? I think it's normally other classes also they don't ask. I think, therefore you guys don't want to do that, Okay, thereafter I don't ask. Okay. Right, next story. Okay, done. This is okay, done. Right, okay. Manage it, okay. Right. Then theory is finished, but normally what they ask, they will ask us to draw the variation of angular magnification with the focal length, right, of the lens. So they will ask some questions because when you use different convex lenses, focal length is different, then angular magnification will be different, right? So in that case, there are some graphs are there. Some graphs are there. First graph is what? First graph is what? First graph is what? The topic is variation of angular magnification with the focal length. So first graph is y-axis is your angular magnification capital M and x-axis is focal length F. F. Right? Okay. Now I raise the boat. I raise the boat. I raise the boat hereafter. Okay. Right. When the simple microscope is at normal adjustment, angular magnification, I obtained capital M equals d over f plus 1. Right. Now, if they ask us to draw the variation of angular magnification with the focal length, variation of angular magnification with the focal length, y-axis capital M, and x-axis simple f, capital M, x-axis simple f, right? We know the equation. Whenever we are plotting a graph, I told you obtain the relationship between those two variables. Since I am plotting the graph between capital M and simple f, I should obtain an equation involving capital M and simple f. That equation now we derive. Capital M equals what? Capital M equals d over f plus 1, d over f plus 1, right? So d over f plus 1, right? My x-axis focal length, right? X-axis focal length. When the focal length is now, actually what's happening very simple, d is a constant. D is the near point, 25 centimeter. If not least distance of distinction, 25 centimeter is a constant. D is a constant. So therefore we know that D is a constant. Therefore we know when we are increasing the focal length, we all know that linear magnification decreases. Basically, there is a kind of inverse relationship between focal length and linear magnification. When focal length increases, angular magnification decreases. Focal length increases, angular magnification decreases, right? When your focal length is 0, just think when the focal length is 0, then angular magnification is infinity. You know why? Right? You know why? Capital M equals a constant. D means 25 centimeter. 25 centimeter something over when the focal length is 0 plus 1. So when you divide a number by 0, it's going to be infinity. It's going to be infinity. If you divide number by 0, it's going to be infinity plus 1. That is also kind of infinity. Infinity plus 1 means infinity. Therefore, when the focal is 0, graph starts from infinity. Okay. So when your focal length becomes infinity, when your f becomes infinity, right? When f is 0 here, when the focal length is 0, angular magnification becomes infinity. Next story, when the focal length is infinity, when your focal is infinity, angular magnification going to be capital M equals D means 25, 25 over Focal length is infinity, infinity plus 1. When I divide any number by infinity, all level maths, when you divide any number by infinity, answer is 0. 0 plus 1 means angular magnification is 1. It's 1. Right? Therefore, when you are increasing the focal length, angular magnification decreases only. When the focal length is 0, angular magnification infinity. When the focal length is infinity, angular magnification reaching 1. Therefore, this graph. Therefore, this graph. Therefore, this graph is 1. A graph like this. A graph like this. Nice, Turini? Nice. Okay. Then next idea. I hope all of you understood the idea. I'm not going to ask whether you understood or not. No need hereafter. Difficult, right? Difficult to do such things. Right? I can understand some based on that. Okay. Majority don't raise the hands. Majority is not raising the hands. Why? If you just click the button, will you get hurt? No, right? Right, I'm explaining something in deep, taking the time, and majority not responding. I don't know why you can't do this. If you don't understand, no, and leave it. Right, if you don't understand something, no point of staying in the class. Ne? You can tell no, I don't understand. Then once again, I can explain. Again and again, I can't explain also. That is true. Ne? Right, if you majority says that don't understand, I will take another few time and I will explain. Right, if people not responding to understood or not understood, okay, right. Hereafter, I'm not going to ask you whether you answered or not. I'm not going to ask. No issue. No need. Difficult. Okay, this story done. Okay, people who wish to come, they will come. People who don't like to come, they don't want to come. No issue. It's okay. Right. Difficult. I am asking every time, do you understand? Do you understand? And not responding. Only one, two. There are two people, two or three people. Every time they are the people who raise the answer. When I ask a question, only they are the people who answer. Therefore, no need to ask hereafter, do you understand or not? I don't mind also whether you understand or not. I have no idea, no issues. Okay. If you don't understand, leave. Okay, leave from the class and leave it. You don't want to join my class also. Right? Therefore, what you do, you leave the class, to go wherever the class that you want, go, no issue, go. Fine. Okay, right. Explaining some deep story and asking whether you understand or not, and people who can't raise their hands at least, no point of asking such thing. It shows about your respect, about us. Okay, anyways, okay, fine, it's okay. Then the next graph is y-axis angular magnification. Y-axis angular magnification and x-axis going to be y-axis angular magnification and x-axis. Don't ask any chat also. Don't you put any chat message. Don't you ask any doubts also. I'm not going to respond. And I'm teaching the theory. Okay, people who want to come, they can come. If not, leave. No need to come to my class. Okay, leave. Okay, I am not the guy who want to keep students. Okay, I don't mind even you join or not join. I don't mind. I don't want to keep people like this. Right? Okay. Right. Okay, hereafter, don't ask any doubts also. I'm not going to respond. Ask from someone else. So your y-axis angular magnification, x-axis 1 over f. X-axis 1 over f in that case. In that case, if I do that graph, I know the relationship between capital M and 1 over f. We know that. Again, same equation, angular magnification equals capital D over f, capital D over f plus 1. Then capital M angular magnification equals D over f means D into 1 over f, D into 1 over f plus 1. Now, what is our y-axis? That is capital M. Capital M is our y-axis. Capital M is our y-axis. And equals 1 over f is our x-axis. Is our x-axis. Then this capital D pretend to be the gradient simple m dash something plus interception 1. Y equals mx plus c graph. Y equals mx plus c graph. A graph like this. A graph like this. Right? So remember this value is exactly 1. Interception is 1. Therefore this value is 1. That story also done. Done story. Okay. Next idea. Next idea done. Next idea done. Next idea done. Next story. Okay. Next story, then that theory is done. Then simple microscope under abnormal adjustment idea. Abnormal adjustment idea, abnormal story. Right. Theory wise, simple microscope under normal adjustment finished. Now we want to talk about simple microscope under abnormal adjustment. Right. That story. In this story. Mm, okay. Mm, right. Okay. Abnormal story. Abnormal adjustment. Abnormal adjustment. Now we know that based on what I explained today, we know if the microscope is at the abnormal adjustment, we all know that final image must be formed at the infinity. Definitely, we know that final image must be formed at the infinity. Some ideas. Final image must be formed at the infinity. Right? Simple microscope consisting only one convex lens. Consisting only one convex lens. Focal length of this convex lens, simple if. Simple if it's a fixed value. Right. Now there is a object. That object is nearby the eye. What I want to do is I want to obtain enlarged image, right? But this time, that object's final image must be at the infinity. So anyhow, I'm going to keep the object. Anyhow, I'm going to keep the object in front of this convex lens. But if I keep the object in front of the convex lens, that image of that object must be formed at the infinity. That means where should we keep the object exactly? In order to obtain final image at the infinity, we must keep the object exactly at the focal point, exactly at the focal point of the convex lens. Therefore, if I mark the focal point capital Fn, the object, right? The object is exactly, we are placing the object in front of the convex lens exactly at the focal point. Object is capital O. Object is exactly at focal point. Object is capital O. Right. Then what we can do, we know that convex lenses, we learned that when the object is at the focal point only, the image will form at infinity. Right. If I draw the ray diagram, the light ray, standard rays, light ray emitting from topmost point passing to the optical center does not refract. Does not refract. Then second ray is the light ray parallel to the principal axis after the refraction passes through the focal point. Pass through the focal point. I take this point as focal point. Very clear, these two light rays are parallel. Since these two light rays are coming towards I told you I is somewhere here. I told you I is nearby the magnifying lens, I is nearby the convex lens, simple microscope. Then these light rays are parallel. When you extend these two light rays backward, we say that image will form at the infinity. We say that image will form at the infinity. If we extend these two light rays backward, we say that image will form at the infinity. So I explained already this ray diagram. Image will be formed at the infinity. Image will be formed at the infinity. Final image will be at the infinity. Image at the infinity. Right? Image at the infinity. This idea. Okay. Then if you draw your eye, you can keep your eye like this also. But I'm drawing the eye somewhere closer to the simple microscope. Is my eye. Okay. Right. Now clear. Now clear. When we talk about abnormal adjustment, we bring the final image at the infinity. Yeah. In that case, you want to keep the object exactly at the focal point of the simple microscope. Then the final image will form at the infinity. Okay. Right. Then what is your alpha dash? Alpha dash, we can remember. If you're finding the angular magnification, we all know that angular magnification means alpha dash over alpha. What is our alpha dash? Alpha dash means we know that angles obtained by final image. Since final image is at the infinity, right? Since final image at the infinity, angles obtained by final image at the I. Angles obtained by final image at the I means our alpha is this one. Our alpha this one. Sorry, alpha dash is one. Alpha dash means angles obtained by the final image. Our final image is at the infinity. Therefore, light ray coming from the infinity. Take like that. This is our alpha dash. Alpha dash. Right? Then object distance. Object distance what? Object is here. Object distance from the optical center. Our U is how much? Object distance exactly equal to U is exactly equal to focal length. This gap is focal length. F. Optical center to focal point gap is focal length. Object distance exactly equal to focal length. Object height is h naught. H naught. Right. This story clear. Then what is alpha? Alpha means when you bring the object exactly at the near point of eye, and if you look at the object from the naked eye, the angle is we call as alpha. Right? Same object is at the near point of the eye, at the naked eye. With the naked eye, you are observing the object. Then tan alpha means what? Tan alpha means what? Is the alpha. Tan alpha means h naught over d. That's totally okay. Right, okay. That's it. This ray diagram is not difficult like before. Simple. Now what's my target? My target is I want to obtain equation for angular magnification. I want to obtain equations for angular magnification. Angular magnification means alpha dash over alpha. You can write down same story. When you're writing, write down that line. Since alpha dash and alpha very small angles, alpha the angles exactly equal to their tan values. Then angular magnification. You write down that sentence. I don't write down. Then angular magnification capital M equals tan alpha dash over tan alpha. Tan alpha dash over tan alpha. Tan alpha dash how much? Tan alpha dash means this side, and this is point capital A. This is point capital A. AOP triangle. Tan alpha dash means opposite is H naught. Adjacent is U, that is if, H not over if, right? Likewise, I can do some stories. I can do some stories, right? Okay. Then tan alpha dash. Okay. Tan alpha dash, we know that. Tan alpha dash, AOP right angle triangle. AOP right angle triangle, tan alpha dash how much? That is going to be opposite is H naught. Adjacent is how much? That is going to be capital T. So that is going to be, adjacent is going to be how much? U, that is equal to F. It's U that is equal to F. And also if you find the tan alpha, this diagram, our tan alpha going to be how much? Tan alpha going to be, opposite is H naught, adjacent is D, H naught over D. H naught over D. Therefore, we can write down finally. Finally, we can write down angular magnification equals, right, from these three stories. This idea, these two ideas, tan alpha dash H over F, H over F over, tan alpha means H naught over D. When you simplify it, angular magnification equals H naught over F, right? Division means reciprocal, D over H naught, D over H naught. These two cancel out. Finally, angular magnification equals, very important equation. Very important equation. Angular magnification equals, remember, capital D over F, capital D over F. When the simple microscope is at the abnormal adjustment, capital M equals D over F. Capital M equals D over F. This idea. Very important. Very important story. Very important story. Okay, in the given space, abnormal adjustment of a simple microscope, and that given space, you can draw the ray diagram and you can write down. You can write down. Simple. Simple story. Simple A, 1, 2 something. 1, 2 from equation simple A, 1 and 2. 1 and those ideas. That's today done. Done. That is done. Okay. Right. Based on this, so we are doing some tute questions. Page number. Tute question. Page number. Tute question. Page number. Right. Page number 34. Page number 34. Uh, Not 34. Okay, where is the question? That question is where? Mm, mm, oh God. Oh. Okay, so we'll do questions later, right? Theory idea done, theory idea done, right? Theory idea done. Now in this case, you want to understand one important point is when the simple microscope is an abnormal adjustment, object is exactly at the focal point, image is at the infinity. Write down. When the simple microscope is at the abnormal adjustment, when the simple microscope is at abnormal adjustment, when the simple microscope is at abnormal adjustment, comma, the object is at the focal point, the object is at the focal point, the object is at the focal point, and the final image will be at the infinity. And the final image will be at the infinity. Final image will be at the infinity. Right. That story also done. Then simple microscope theory-wise finished. Normal adjustment, abnormal adjustment, theory-wise we complete simple microscope idea done. That is done. Okay. That is done. Okay. Now, before talking about compound microscopes, first of all, I want to clarify some theory points with you. Before talking about compound microscope, some stories clarifying. Some stories clarifying. The first story I want to tell is okay. A simple microscopes, normal adjustment. Normal adjustment, angular magnification, we obtain that capital D over F plus 1. Abnormal adjustment, we obtain that angular magnification equals exactly D over F. Both the equations, first you want to understand, in MCQs, they can give this point. In MCQs, they can ask this point. In order to obtain maximum angular magnification by using a simple microscope, what should be the adjustment that you want to do for the microscope? In the exam, they can give MCQ point. In order to obtain the, for a given microscope, for a given simple microscope, if they have given a simple microscope, focal length constant, focal length constant for a given simple microscope, focal length is constant, they can ask you capital D value is definitely a constant. Capital D means, remember, 25 centimeter. Capital D is 25 centimeter, therefore capital D is also constant. If they have given a simple microscope, focal length is constant and capital D value is constant, they can give an MCQ point for a given simple microscope. In order to obtain the maximum angular magnification, what should be the adjustment of that simple microscope? Then that should be normal adjustment. Why? Because normal adjustment only angular magnification is D over F plus 1. Abnormal adjustment, angular magnification is only D over F, right? So therefore, red color pen write down, for a given simple microscope, for a given simple microscope, for a given simple microscope, the angular magnification becomes maximum. The angular magnification becomes maximum. The angular magnification becomes maximum, comma, if it is adjusted to, if it is adjusted to normal adjustment. If it is adjusted to normal adjustment. Right, me? then you can compare, you can write these two nearby and you can understand DEF constant. This is DOF plus 1. This is just DOF. Therefore, for a given microscope, maximum angular magnification will be obtained for a normal adjustment. That's theory. That point also I explained. The next theory point is now what will happen? Now, now you know that our ultimate goal of doing such ultimate goal of using such microscope is obtaining a larger angular magnification. If we can obtain larger angular magnification, final image size is very large. If we can obtain larger final image, yeah, we can go detail, right? So therefore, it's really better. And we all, scientists, they always try to obtain larger angular magnification, right? Okay, you can consider one of them. Okay, consider any of these two equations. If you want to obtain larger angular magnification, what you should do for the convex lens? The focal length of the convex lens should be reduced. Okay, already we are using a short focal length convex lens as the simple microscope. Already the convex lens that we are using for the simple microscope, its focal length is almost smaller value. Smaller focal length means what can you say about the curvature of the simple microscope? The convex lens that we are using for the simple microscope, its focal length should be smaller value. For a convex lens, focal length small means what? For a convex lens, its focal length small means its curvature is very high. Smaller focal length means its curvature is very high. Right? Let's say, okay, already the convex lens that you are using having a smaller focal length, its curviness is very high. High curviness, high curvature. In order to obtain more and more larger angular magnification, we want to reduce the focal length more and more, right? You reduce the focal length more and more. If you can reduce the focal length more and more, then the angular magnification will become large. But the problem is, in the attempt of reducing the focal length more and more, what will happen is curviness becomes high, right? The curviness becomes high. In that case, what will happen is there will be some issues like we name as, right? Our ultimate goal is from the simple microscope, if you can obtain the larger angular magnification, super. To do that, we want to reduce the focal length of simple microscope. When reducing the focal length of simple microscope, the problem is curviness becomes more and more large. Curviness becomes high. The problem is when the curviness becomes so much high, there will be some optical problems named as spherical aberration and chromatic aberration. They don't ask what are those. For your understanding, I have put that there will be some problems like spherical aberration and chromatic aberration. So first of all, we'll try to understand. So what you told? What I want to increase the angular magnification. In that case, I won't reduce the focal length. In the attempt of reducing the focal length, I realize curviness of the lens becomes high. When curviness of the lens becomes high, you are telling that there will be some optical problems like spherical aberration and chromatic aberration. Right, okay. Now go to the important point there. Page number 25. Important. When the focal length is reduced further to increase the magnification in a simple microscope, lens curvature becomes very high. You want to highlight the entire sentence, which introduces severe optical aberrations. The first one is what? Spherical aberration. It says what? Spherical aberration means rays from the edge of the lens do not converge at the same point as central rays, causing blur. I will roughly explain, not important. Chromatic aberration means different colors focus at different points, creating color fringes. Right? Okay. So when the curviness becomes high, what will happen is, if I roughly explain, the light rays, just consider parallel light rays, we know we know for a convex lens, we learned that if the light rays are parallel, for a convex lens, the light rays are parallel, all the light rays will converge exactly at the focal point, right? That's a normal idea. When the curviness of the convex lens becomes very high, what will happen is we are expecting these parallel light rays to converge at the same point. But what happens is they are converging at different points. Because of the curviness, they converge at different points. Right? Some stories, what happens, it will break into colors and there will be lots of problems. Then we understood one story. One story that means by reducing the focal length of the convex lens, by reducing the focal length of the convex lens, there is a maximum limit that we can increase the angular magnification. By reducing the focal length of the simple microscope, there is a limit, there's a maximum limit that you can obtain the angular magnification. That means there is a minimum focal length. There's a minimum focal length which provides maximum angular magnification. Thereafter, when you try to reach the focal length beyond the minimum, then we can't expect magnification. There will be errors. That case, summary simple. Summary simple, right? Okay, I understood the idea. Focal length, I reduced to increase the angular magnification, but there is a certain value of the focal length. Beyond that focal length, we can't reduce the focal length and we can't obtain maximum angular magnification. Right. In that case only, they're suggesting after you reach that minimum focal length, if you want to further increase your angular magnification, they are suggesting use two convex lenses, right? Because using one convex lens, there is a certain maximum value that you can obtain the magnification. Beyond that, you can't obtain the magnification further, you can't increase it. In that case, they are telling, okay, in that case, use two convex lenses, then you can do this idea. Then only we are talking about compound lenses. That's why we went to compound microscope story. So compound microscope means by the name you understand, it contains two convex lenses. Compound story, we know that it consists two convex lenses to overcome these limitations. Look at read the tute. Two converging lenses are used in a compound microscope when higher angular magnification is required. Okay. Two converging lenses are used in compound microscope. Number one, we are giving a name. There are two convex lenses in the compound microscope. We are giving a name for them. One is write down objective lens. We are giving a name for the compound lenses. One we call as objective lens. Other one is we call as eyepiece. Objective lens. Other one is we call as eyepiece. Right? Okay. Objective lens. Other one is we call as eyepiece. Other one we call as eyepiece. Right. Okay. Okay. Right. So now we'll talk about this component story a bit later. Okay. I'm stopping the class for today. Right. Okay. One story I will tell you. Okay. I don't know whether you can find good classes. I don't know. One thing I will tell you. This is the way. See, every time our mentality also not be very normal. We all have problems. Right. Sometimes we are in good mode and we are in bad modes. Okay. That's very normal. We are human beings. Right. Now, when we are doing an online class, right. Okay. When we are doing an online class, right. Okay. Now, you should have if you are joining online, if you're watching the recording, no issue. It's okay now, everyone. If you're planning to watch the recording, also no issue. I don't mind. Okay. If you're joining for live classes, right, in a physical class, just think that now in a physical class, now I am asking, now you all are physically, you are in the class. Normally, I'm not I'm strict guy only. I'm a bit strict only in my classes. People don't even talk in my class. In the physical class, now you all are sitting in the class and now I'm teaching something. I'm putting very big effort and I'm explaining. Difficult stories, not easy. By drawing the diagrams properly, nicely, right? Some people don't draw like this also, okay? Right, then I'm explaining something very serious and I'm asking that in the physical class, do you understand? So some people only now, there are, let's say there are 15 people. Only two people raise the hands. The remaining don't raise the hand. Then what is the conclusion I want to make? Only two understood and remaining 13 didn't understand. No. If not they understood, then they don't raise the hand. I don't know. Right. But I feel like it's annoying for you asking, raise your hands and do you understand? It's annoying for you. I think it's not suitable for online classes. Hereafter, I'm thinking like that only. Right. Raise your hands. Do you understand? If you don't understand, hands up. How many of you got the answer? Hands up. That stories I'm not asking. Hereafter, I'm not going to ask you from you. Okay, no issue. Right. I just keep on explaining. Right. I don't mind even you understood not. I even don't ask that. Do you understand also? Right. What I do, I keep on explaining with my level. I keep on explaining. I don't try to once again explain something. It's a waste of time. That's why I'm feeling a trouble to finish some theories quickly. It's easy for me also. It's easy for me also. We'll do in that way. Okay, we'll do in that way. That's better. All right, then one quickly I can explain the theories and I can go to next sections also. Right, then it's all about me. I don't know. I'm wondering now. If you don't understand, you can tell. Sir, I didn't understand. And then once again, three, four times can't explain. That's not practical. Three, four times. If you tell I first time I explain, don't understand. Second time also you ask saying that don't understand something. Don't understand something. Then once again I'm explaining. Third time also when someone is asking don't understand, I can't explain. Then I can't do the class name. Right? Year after, okay. Year after we do in that way. Okay, if there is no any support from your end, why should I just die like this? I think I am the one who's dying like this. I don't know any other classes. They are doing like this. They are just sound quality absurd. They are not explaining properly. They are not drawing properly. Lazy way. They are doing something and they are taking the money only. I am the one who is putting many classes here and there, and I am the one doing all these things. But at least for that, I don't see. I know you don't want to respect me. I don't expect that from you. But at least if I ask you, do you understand? No one is raising that. Only one that you should. There are typical two, three people. Every time there are people raising the hand. There are people who are asking doubts. They are the people who tell an answer. The remaining set just keep on looking like this. I don't know why. I don't know why. Are there any reason? I don't know. But therefore, hereafter, what shall we do? No, we want to finish the class properly. It's very seriously. Therefore, I'm teaching my normal way. Hereafter, I don't ask, raise your hands. Do you understand? I don't ask any questions from you also. Right, tell me this answer. How many? What is the focal length? I'm not going to ask the stories from you. Theory class only theory. Paper class also keep on explaining. That's it. Okay, that's better. Okay, I'm finishing the class today, so we'll plan some classes upcoming days. Okay, right. I'm leaving.